Okay, so it's recording on a cloud. And now let me share a screen. Okay, and you see here, I share the screen. And unfortunately, I have one big screen. This is Surface Studio because I can on that one write, but you can see now all of you, which is 5 of you now, are you're seeing yourself on it, correct? And seeing me talking, right? Okay. And then do you see my email?
Yeah.
Okay. Just do this. When I say I'm going to ask a question, just say 1 finger up or 2 fingers up, so I know that you are up there. Okay, very good. So now one other thing is I will show you on the navigation. You have this. If you want to ask any question, please just make this up. What I call it. Such that you wanted to ask a question. So therefore, when I see the raised hand, that means I will let you ask the question. Please don't overdo it, unless you feel that it is important for to follow up right away rather than waiting for a question and answer at the end of it. Okay, so understood. I appreciate your, how to say, interaction during the presentation, and just raise a hand, and then I will give each one of you a chance to ask the question such that we can proceed with the full understanding. All right, this is what I sent you email this morning. Did you get this, all this this morning? This is an update, what's called an update from Faraday and Tesla until now. And here is one link. But before that, I sent you another link, which was which I asked you also to preview before lecture. I sent it last night, so you had a couple of hours to look at it. But in any case, let's look. And this is your access, so everybody had this access. Well, let me now open this first lecture, which is recorded on video. By the way, I have a question for all of you. Are you all able to join to my YouTube channel? You know how to access my YouTube channel. Well, Chris, you seem to be the only one, but oh yeah, not Andrei Markovich has. I'll send you now with the email how. Well, I don't even have to send you. You have access to my YouTube. How? Because any one of these, either this YouTube or this YouTube, will get you to the particular video I recorded. But once you're on that video, you'll have a 50 or 100 or so recorded videos, which I recorded while I was making presentation in the previous 2 online classes, which are useful because they are kind of summarized. They're not all 2 hours or 3 hours, but summarized a couple of important presentations. So you're welcome after today's talk to actually go and look at my YouTube channel. And what I'm going to doing now, and I'll talk more about it after this lecture. What is my big plan? My big plan is now I have people who are helping me now with setting up a new website, not on a Power Electronics LinkedIn Institute, Power Electronics Institute, but setting up Power Electronic Academy website on Facebook, and being able to, and I'll explain a bit later what is the plan. The plan is to have all of you, maybe right now is appropriate to ask, how many of you are already signed up on WhatsApp, which is a special application from it? Listen, I want you to understand one thing. Listen to me carefully. All Google, including Google Chrome, which I use as a general method to access all of this, the emails on Google, the emails on Outlook, on Outlook, Microsoft, they're all crap. because they're loaded with a bunch of crap. 95% is people advertising. Worse yet, my, let's say, text messages, which used to be something that was relatively personal. Now that was also encroached. I have a T-Mobile, and what happens? I get a 99% of the text messages where people are insistent to leave their let's say, advertising, whatnot. So I have a same person going 10 times and putting the same, and there is no way to stop it. At least the T-Mobile didn't figure it out. I'm looking now with the iPhone and Apple, which has ability to at least. I was trying always to say, T-Mobile, you need to have text messages only to those who are in my address book, and I don't respond to anyone who is not in my address book. Anyway, the point I'm making, my future posting that I'm working now on will have access to, people have direct one-on-one access to the WhatsApp. You can apply it for free. It provides you basically, 2 billion people are connected to it. It's one-on-one encrypted, and I have ability now to generate at least 500, but maybe 5,000 people who can join on a WhatsApp. And my objective is that my website on Meta, Facebook, is going to be connected with the people who can join all the time. So you can have a group connection, and we can have a continuous discussions throughout the year. Okay, so that's a basic introduction, and let me know how you feel about it. And to start with, if you join as individual, and you can join with your cell phone, it's like Viber. The main connection is your cell phone. If you have a cell phone, then you can join on a WhatsApp, what we call, give you a explanation directly, because everything is now cell phone centric. But once you have a cell phone connection, you can use that to make not a web connection, but make a direct connection to your local computer, because then you can have audio, video, chat, you name it, okay? And then I can set up, if you all set up individual, I can set up a group account for everybody to be connected from now on. Okay, so that's a little bit of a pep talk on that. Okay, so let's now go and open this one. And this presentation is, first I made like a shortcut to get you to fully understand what has happened. Oh, by the way, why I'm doing this lecture now, because I'm in the now process of fixing, leading the money. I'm in the process of fixing the, and here it is, yeah. Okay, I'll put also, the beauty of that is that now all the presentation can be transcribed, you know, so actually what is being said on a video is also shown in English text, as a text on it, okay? And this was my first presentation of Faraday and Tesla, which was made in a different way. It was made that my video presentation was following the script, and then when a script mentions some drawings or some PowerPoint slide, then I add a slide to it. So this has very few slides, but it has how I say, my general talk like this. The next presentation I'll show you also from Faraday and Tesla is done different. It was live, and it was one that I showed the presentation, all the slides, and then I'm in a corner making the comments. Okay, so you'll see both ways how I'm doing it, and I hope you'll find it, how I say, enlightening. So now I included a capture, so let's get started, okay? Unfortunately, I think I was hoping that more people will sign up, but look, as I'm recording this now, that means after this presentation today, I'll send this link to this presentation today, so all the people who are currently registered will be able to review it and hopefully be how you say, motivated to join my next presentation, which until I fix this, which will take a couple of weeks, I will send you some of my free webinars to review, and then maybe make another video presentation on these critical webinars I gave in the past. Okay, so let's say here why we are doing this. Okay, how do we? Okay, here. Now you see this whole, correct? You see the whole screen, and then over that is people who are attending. As I said, feel free to raise hand, as on this navigation, if you want to have a question, which is important for a continuing understanding this presentation. So let's get started. And it's being recorded. So now, this is my music introduction to the course. Ready to go. Okay, everybody listen. I can hear. Okay. Let me tell you this. I have nothing to do with this one in a century cold spell and storm in Texas. Okay. The comment to that is, when I made this in 2021, there was a big storm in Texas, and guess what? The first thing they got is a electrical high voltage distribution line of Nikola Tesla. Were broken, and they had suddenly loss of electricity for a couple of days. And everything runs electricity, so they were in a really horrible shape, because then water didn't get provided, etc. So I was just making at the time comment to that. Okay, because some would think that's why I engineered that, so we can show how the electrical power distribution throughout the world is important, and we cannot live without it. Okay, and it just came in time for me to make a point that how important it is, electrification, that Nikola Tesla, the famous inventor from Yugoslavia, and who moved at age 25, coincidentally just about age like I moved, so and changed the world. One thing that was clear is that Texas didn't maintain their networks, didn't weatherize it. So now what happens is the gas pipes froze, and they couldn't use to generate electricity. One nuclear out of 4 nuclear power plants went down because of the cold weather. The water pipes, and irony is that they had a fires that they couldn't distinguish. Because the fire hydrants also were not working, and so on. So the point making is, it is very, very important that life, let's say, electricity, electrical utility networks are lifebloods, like a blood in humans. And if it stopped working, then nothing works. Okay. Now I'll make while you are reviewing what is put here. I will make a comment, which I will more explain toward the end of today's lectures. Now the time has come that we have to look and consider at something which was impossible at the time of Nikola Tesla and Edison War of Currents. As you know, Tesla was advocating his alternating current that he invented, and especially 2-phase and 3-phase, his alternating motor, induction motor, and synchronous motor. And Edison was straight against it, and he was using his DC system to show how they can very effectively kill the humans, but also he demonstrated killing the elephant, the big elephant. And what it is, at times of Edison, even Faraday, and as I'll show today, was not recognizing importance of alternating current. Part of a reason because they all said it's useless, because as you have alternating current, positive cycle will drive the motor in one direction, negative cycle the opposite direction, and it wouldn't move. So they consider that, that's useless. And as I explained here, Faraday was, and also Maxwell later realized that what is needed is a change. And Faraday established Faraday's law of electromagnetic induction, but did not invent a transformer, didn't even consider it. He, in fact, made a generator, DC generator, using a disk and moving the disk inside the magnetic field, And of course, you can get a DC voltage that way, but not much of a DC voltage. But they knew at the time that you can use a transformer, two windings in a primary and secondary. If you interrupt the primary winding with the current, with the switch, then you use a turns ratio transformer. Then by turns ratio transformer, you will get the high voltage impulse on a secondary side. And of course, then you can use to kill the elephants, and so on. Or actually, the first electrocution was done by using alternating current of Tesla rather than DC current that was not as effective. So they tried to, there was a call. And in fact, later, just to briefly explain you, later it was Maxwell who proved why you cannot have a DC current on a primary to generate the DC current on a secondary. You need to have a change of current on a primary, and only during that time. So basically, the transformer is made like a transient device, but not some device which works around the clock with a continuous AC voltage and continuous AC current. Okay, so let's continue on this. At the end of the lecture, I'll tell you why now it's a time for us to switch to high voltage DC transmission and distribution of power. Why? Because now we have all ingredients to it. However, we don't have proper switching DC to DC topology, which will include isolation transformer and provide what I was just saying, provide high voltage DC distribution. What is common to both that people don't realize is the following. High voltage AC distribution, the Tesla basically pioneered, an induction motor and synchronous motor. It can use a transformer at 60 hertz and then transfer the power long distances with a two-phase, three-phase transformer, and then on the other end, step it down to use it. You have, and that transformer does everything except it is at 60 hertz, which means the size and weight and everything and power are proportional, size and proportional to power. So you can use kilowatts and megawatts of the power, but you're stuck with a 60 hertz. However, now we have a 20 kilohertz just of audio. We can use it. However, what I'll show you that all this switch mode power electronics went in the wrong direction for like 50, 60 years and used what I call, any place you use inductor, I call it now fake inductors. The lecture you will see more in my class when we get fully going, because buck boost and flyback, especially flyback, things should have never been invented, in my point, okay? And why? Because we can do now everything, step up, step down with a transformer and without any kind of a fake inductors, okay? And because these inductors, I call them fake because they're not AC inductors. That's a key problem. Most of these isolated converters are also fake because they don't provide true isolation, and for I explain. Okay, so let's now continue on this way and in a preparation for a big bang at the end.
Actually, they were in New York, and Westner will remember or learn about it.
there were many blackouts in New York. There was one famous blackout in 1965, and there were many after that. And that 65 blackout, I think the blackout, there were 3 million people in New York, and number of states in the United States, even in Canada, were blacked out for a couple of days. And the thing is, that was a nice blackout, if I can call it. They lost power, they lost lights, people couldn't go to restaurants, so they were stuck like we were now with staying at home. And they said, statistics show that 9 months later, just to the date, there was a sudden spike in new births in New York. Okay, so that's related, it seems like related to that blackout, okay? Okay, so now getting back to this here, I think it is a tribute to Nikola Tesla that in just to put the things in perspective, and I want to put a general introduction so we see where I'm coming from. One of the mysteries is what has historically, who contributed what, and subject of my presentation today is who really invented the transformer. And I'll just give you summary of what you're going to see basically introduced in this lecture and backed it up with some material and documents. It is well known that, and one thing is what we should know just now, that now is 200 years when humanity first time realized connection between electricity and magnetism. It was long 2000 before that there is a magnet that you can that attracts another magnet. So there was magnetism. Electricity came much later, around 1810 or so. Volta come up and developed with Galvani and Volta actually developed a battery to have a continuous source rather than using rubbing and generating the electricity by charges and so on. Anyway, in 1821, it was Ørsted, Danish physicist, who made experiment where he put a DC Volta battery and conducted a DC current and found out, because that time people used a magnetic needle for a compass to navigate. And he found out, yeah, the current, DC current in a wire causes a force of magnetic needle to orient in particular direction. And then it was Ampere around that time. He came with Ampere circuit law, who established a quantitative relationship, how much DC current generates what kind of force on a magnet at certain radius away from this current carrying DC current carrying conductor.
Okay, the point is my second presentation will talk more about and show this Ørsted experiment, which established a connection between electricity and magnetism in 1821, and then everybody was in awe of that and trying to generate constant current to generate on a primary to generate constant current on a secondary. However, it was Maxwell who really followed up after the Faraday and proved that you can't do that, you know, and why, and explain it in a physical sense, why you need a change of the input current in order to create a change of the output current, and no way to make a transformer which should be DC to DC transformer, no such thing. And unfortunately, that also proved the point that both Faraday, as great they are, and that's why I call this lecture today also tribute to Faraday and Maxwell, but they both missed the importance of alternating voltage and alternating current. But of course, they are great in themselves because they set the stage for Tesla, who came after that and was able to introduce alternating generators and alternating motors. Okay, so I'll discuss that. And
and also finding now how now we have all the tools available, but we need the right converter topology and try to make emulate what would look like DC to DC transformer. What that means: DC input voltage, DC input current, DC output voltage, DC output current, but in the middle, someplace is an isolation transformer operating at 20 kilohertz or higher, which actually is by turns ratio able to step up and step down voltage. So that means once we have this situation, we can think about high voltage DC transmission conducting the power under like signals under with cables transferring the signals from Atlantic Ocean and so on, but from US to Europe. But now we can use a power that can be actually embedded inside below the ground. So you wouldn't have this ugly distribution line, which because of AC and other corona effect, etc., they have to be at a very high post carrying this high voltage current and not to cause interaction and discharge. So therefore, there's some great benefit of being able to transmit the power with the high voltage DC. But one thing, what is also important is that high voltage DC or DC voltage and DC current. What is the product of DC voltage and DC current? On input, constant power. On output, constant power. What does it mean? There is no storage. Just like Tesla two-phase, three-phase system, there is no storage. Why is that important? Because the people who are nowadays, and let me put my 10 cents to what Elon Musk is doing. He actually created and convinced the Australian government to make big batteries backup. So he's creating DC power on batteries and feeding the AC utility line, which requires a big conversion from DC to alternating current. But the best point, he doesn't understand, that you can make a 5 megawatt battery storage. Why? Because we can't even put the 50 kilowatts in a car, and yet he's dreaming about this nonsense of supporting utility alternating line with the batteries. And we're at the point, missing the key point, that alternating current of Tesla, two-phase and three-phase, does not store any energy. 1% is used just for circulate and create a flux in a core, and 99% is with the speed of light transfer from primary to secondary. So you can have a power generated in Niagara Falls, and then with the high voltage distribution line, which are very efficient because of very high voltage, low current, can be sent to Los Angeles and immediately used to run factories, run motors, etc. So what a waste and what a bullshit that I call. But nobody calls him on it. He's a visionary, visionary now in exploding his rocket, and hopefully next time when they send the astronauts with it, then all astronauts won't be blown up. But anyway, this is my take on it. Granted, very personal, but the reason is because I feel he is very much exposed, and everything he puts out is made to like God sent, but yet he doesn't have basic understanding. He never really finished. He was like, I don't know, physics student at Stanford and never finished it. Quit. Okay, back to the subject. So let's go further. And you know what? It's interesting part is that at 1821, Faraday, who was then already at age to participate in the science, he tried, like everybody else, to do the opposite. He said, well, if the constant current, DC current, can generate the force on a magnet, can we have a permanent magnet and generate a constant current in a wire? Of course, this turned out to be impossible goal. And he was trying it like everybody else at the time for 10 years, from 1821 till 1831, to do exactly that. And in the process, he did make DC generators, which turned out to be useless at the time and never really came up to anything. But using his disk and rotating and so on, magnetic disk and mechanical current converting into DC voltage. But in 1831, he came to his famous experiment that he was trying to establish connection between electricity and magnetism and force the constant magnetic force to generate the constant current. He didn't succeed because he, story goes that in a room, he had a very big switch, and he made a transformer, which I'll show you. It is now basically in a Museum of Science and in London, Royal Museum in London, and there's a special room devoted to Faraday. And in Faraday's room, there was a transformer. Really looks like a transformer. It is. It was a big toroidal core with a primary winding, secondary winding. And what did he do? He put on a primary side.
Sorry.
They considered this alternating current as useless because, let's face it, if you have sinusoidal current, you have positive, it will force the motor to go in one direction, and if you have negative part of sinusoidal current, it'll drive the motor in the other direction, which means it won't move. So gave up on that. You could do that. There's ratio of change of the current, which...
Let me make a point here. You guys are in switch mode power conversion. Okay. Let me give you a couple of things which shows that actually Faraday did not invent low electromagnetic induction and use the transformer-like structure. And the whole point is that the people now assumed, I don't know, 2, 4, 5, someone else joined. I didn't see. Let's see. Yeah, there's another one that joined. Please join with the audio and video. Okay, whoever is joining. You know, I'd like everybody to join who can join video. Okay, so let me continue on this point. You know, switch mode power conversion. How many? Let's have a raise of hand and see how many of you have. Let's say, I'm trying to get.
You can't buy great conversations or moments that matter, but you can invest in them. At T. Rowe Price, our strategic investing approach can help you build the future you imagine. T. Rowe Price, invest with confidence.
Consumer Cellular, this is Sam. How may I help you?
Who is talking? I don't understand. I don't understand who is talking.
About that, the Consumer Cellular will be the same exact coverage as the main carriers, but
Can you figure out who is calling?
Silver is breaking new life.
It's Frederick, I think.
Today's great silver projects in America is about to get bigger. BlackRock Silver.
What is happening? I don't.
dishwashers.
Frederick, please mute yourself.
Getting laundry truck.
Do you see?
Dryer. What's
I see who is actually interrupting this.
fresh. If your toilet won't flush. Look, American Home Shield is there in big store please covered boxes and hoses. So you stay on course. Yeah, but protect.
I think, Dr. Shu, you can mute all the audience, so the background noise, not to annoy the listener.
Background noise. Listen, I actually sign up for YouTube Premium such that there will be no interruption with the bullshit other people interrupting with the advertising. But okay, let's stop for now. I have a question for you. And Sammy, yes and no. And the question is, how many of you are familiar with the flyback converter? Raise your hand. Okay. I don't see everybody. Okay. Everybody is familiar with flyback converter. Some people in our field
claim flyback is fantastic. You know, you have only one switch on the input side and diode on a transistor on the input side, and on a secondary you have a diode flyback converter. It can step up voltage and can step down, doesn't have inductor in it. It is a transformer. This is a fake transformer, you understand? Because the flyback is when you turn the switch on, you store energy in magnetic core, and you can store it because it will be the magnetic core cannot take only very little primary current, which is a magnetizing current, which is 1% of the load current, and therefore it will be basically dead end. It will be saturating in the core, magnetic core. Instead of having huge magnetizing inductance, it will be shorted. So secondary will be shorted. So if you put a switch on the grid, all you need to do is to make a flyback transformer. What? You put a diode on the secondary side, right? And then you're operating a transformer with the storing energy in a core and then releasing it from a core into the output. Flyback transformer. You can use the turns ratios to step up, step down, no inductance, great. Except it is not transformer. It is an energy storage inductor, which has a DC bias. And when it has a DC bias, what is the problem? You have to put an air gap in it. And you know what? If you put an air gap of 1 millimeter or less, irrespective of cross section, 1 millimeter or less, what you're going to get? You're going to kill inductance of Faraday core, which has a relative permeability of 4 to 10,000. You're going to kill it by 4,000, and this is going to look essentially like a air core transformer with no magnetizing inductance, which with no large ability of the core, which means it's useless. It becomes an air core transformer, you know, because it has a huge current, you know. But the funny thing is,
It's a cool shirt.
hello,
Caesar's. We bought that a long time ago. But it is an XL.
Okay. They got 6 houses going on at the same time.
what two
6
things
houses
about
going on at the same time.
let me stop sharing for a second and see where that comes from, because I think we can see here on YouTube. I guess I can look at my YouTube and see what is interference. Okay, we are learning, you know. It's unfortunately
Turned out my course was today.
what
I started late, but I didn't miss much.
Well, that's a real uncommon carcinoma. That's a skin.
Yeah.
Very uncommon. Very fast growing. Like you get that, you know, it's-
There's a piece in the New York Post about an overlooked sign of cancer, and that would be trouble swallowing. Doctor, that sounds like a bit of a scare to me. What do you think?
Well, dysphagia is very common, and that's the thing. That's when you have difficulty swallowing. You need to see a doctor if you have difficulty swallowing right away. You can't wait, and it's associated with head and neck cancers, and it's associated with it's associated with head and neck cancers, and it's associated with cancers of the esophagus. So you have to be seen right away with that particular type of thing.
Yeah, Doctor, I suspect you've got a couple of dermatologists who for that. If you will be still, listen to this.
Professor Cook, I think it's the voice is coming from Frederick.
The CDC
Say it again.
Again.
The voice is
You're not
coming from
working.
Frederick.
from where from? It's a problem is, you see here, I have premium. That's not supposed to interfere with my presentation. And I don't know, it's just kind of random. So I'll have to figure out and talk to YouTube and find out what the hell is going on. Okay, sorry.
Professor Chuk, if you could mute everyone except yourself, it's coming from Frederick. You know, it's pretty clear that it's coming from him, and I think you have the ability to mute everybody. I don't think anybody else does.
Okay, so if I mute it, and you see it's coming from whom? Frederick? Who is the Frederick?
Frederick Crowfoot.
So let's say if I mute everybody, let's see here. So you think that someone purposely joined and then is hiding it, so he's putting his own talks to interrupt my lectures. Is that correct?
Yeah, I mean the audio was coming
Yeah,
from
it's
Frederick.
correct.
But what do you see, Frederick? What do you mean? A particular name? What do you mean, Frederick?
Frederick Crowfoot.
Can you you see, I can actually on my presentation, I can actually include, let's say, here, and I can include this. See.
Oh, there, I am muted. He is not muted.
Listen, let me do this. I think yes, I can mute everybody. See here, I can mute everybody, right? So now everybody is muted, and you're right. I'm the only one who is talking, right? Is that should solve the problem?
You are not muted, everyone.
Oh, I see. That's the Frederick Crowfoot, right?
Yeah, correct.
So someone joined. Let's do this. Let's mute him, and then done deal, right?
Yeah, correct.
Now he's muted, and then I can first of all, now I see that he's on the list enclosed. This is Frederick Crawford. How it's not he's not showing his face, then I can mute him, but I can now unmute it, and because I have him on the list, and only mute him, correct? So that's what it is. Let's do this. And then, where is that Frederick? No, this is everybody is muted. I want to everybody unmute.
I'm unmuted.
What is it? Okay, let me do this. After unmute, you are all muted, then I can unmute, mute. No, they're all muted. Let me go to this chat. You see here. Now I have a control meeting chat, and everybody has here. My audio is not working yet. I will put 10 hours on black outside there. Okay. Okay. Thank you. Your correction is okay. Now we have this Frederick Crawford, and He is muted now. Can I unmute each one of you? Ask to unmute.
Hello, Dr. Chuk, can you hear me?
Who is calling? Who is calling? This guy, Frederick Crawford, is muted, but I think I can have a list here who are there, and hopefully I can block him out completely, not only mute, but completely. So, and then I will report this guy to be another hacker, you know. He may not even be under this name. He may be inventing this name and just to show up to stop my lectures. And new messages, this is a message. Oh, what happened? This guy's removed himself. When I made this threat, he removed himself. Did you see that?
Yeah, he exited.
What?
He gone outside. He exited from the class.
Yeah, but you know, he's playing the game. You know, he is off the class and then he joins the class whenever he wants. So I need to find out how to navigate it. Now you can see my pain with this course. There's so many evil people in this world, so many evil people. We have to find them and put them in prison, in jail. End of story, right? You know, I'm trying to do an honest lecture and so on, and I get these assholes to stop my presenting, and he's probably alter ego. He has different name, and he's another hacker and so on. And that's horrible, but because I never had that. But I think next time what I'm going to do is, and I avoided that because I thought it was pretty safe. When I started this online classes several years ago, I had actually everybody who signed in, and so-called they would sign in, and I would let them in, and I had a control. The people will sign in, and we'll have a list of the people who actually sign up for a course, so we couldn't have someone coming on the side jumping on a course. But to have this evil guy, you know, a fraudster, to come on a course and in and out and so on, I think this sign up took quite a bit of time. So that's why I wanted to avoid it. You know what I understand? I wanted to avoid to, you know, as the people join, authorize, this guy wants to join and I authorize it, that guy wants to join and so on. But now, because I provided this general link, a shortcut, and everybody can join, because, you know, with my shortcut, I'm not authorizing anybody. Anybody who has this shortcut link and he knows I'm going to lecture now can join. And now I realize that's a really serious problem. And I'll have to, in a future lecture, have to basically, how to say, eliminate it, or at least find a way where someone joins that I don't have to look at the list. I simply have ability not just mute him, but stop him of accessing, you know, period. But right now, let's see, you guys are all muted. Let's see how I can unmute all of you and then have a look. And whenever he comes on, just mute him, because I think there should be a way that that I can mute any individual person, which would be good on a Zoom, because that means if someone joins, I don't care if he can show his face, but he cannot interrupt with the audio, right? So let's see how we fix that. Can we, let's say, speaker? None of you. Can anybody of you use the voice? Can I hear anybody of you? Are you?
Can you hear me, Dr. Chuk?
Who is that? Andre?
Assad, can you hear me?
Yeah, I hear you. What about you others? What about Vasily?
So it looks like everyone can unmute themselves.
Oh, everybody can.
Yeah, Professor Chuk,
okay.
I can hear
Listen, that's great, because finally, you see, some of you, like Assad, you still have that your microphone is muted. I don't understand. You just talk to me and then.
Yeah, it's working. I muted myself.
Oh, you okay? Don't play the game. I have enough of these jerks, you know, that you now play the game muted and unmuted. Okay, so at least now, Vasilia, you say thing. Can you hear me?
Yeah, I can hear you.
Yes, yes.
Yeah, we can hear you.
Then apparently when you start talking, it removes this microphone bullshit, right? Because the microphone showed that you're not but now they're all, let's go back to my presentation. You're now all on it with a sound. And if the other guy comes on, I think I can, each particular guy, I can mute. And then done deal. Then we solve the problem at least, okay? Thank you very much. And let's get back to my how to say, share screen. No, what I'm saying, I don't need this chat. Okay, so I have no chat. And then we go to the presentation, and that is when I was before Google Chrome. I can go to my email, open it up, and yes, okay. Just be patient until I find out information. Update. Okay, I'm here on it, so now I'm going to share the screen. Now you see my screen, right? And you're all on it, so I'm going to watch, and you let me know when this guy showed up, you know, voice your thing, and then I will just mute him, okay? And I still have, I mean, you still show that your Microsoft is muted, okay? Can you unmute? Yes.
I am fine. I self-muted myself.
Yeah, but what I'm saying is don't confuse me, please, because same thing, Andre, because your microphone is muted, so I don't know if you can say something or not. Okay, so unmute.
Yeah, in general, I think it's a good practice, Professor Chuk, if someone is not speaking, to self-mute themselves, so not to annoy the other audiences with the background noise. That's why, and whenever I want to speak, I will try to unmute myself and then go ahead.
Yes, I mean, but I don't know that the people are sophisticated like you are. Most of the people don't have microphone or so on. And for me, it's important because of the things like happen now, you see, because that will give me control. Maybe in the future, I may have more than one guy who is trying to interrupt things. And then as we see who that guy is, we'll show that his microphone is on, and I'll just mute these guys. And that way is a shortcut that I don't have to spend half an hour to trying to get everybody on board, okay? So, Chris, Ahmed, Andre, you are not muted. You don't show the video for a reason that you said network conversion and so on. Okay, let's go back to my presentation and see where we are at now. So, you see my screen with the email, correct?
Yes.
Because I shared it, right? And we'll go to that first presentation and find where we stopped it. Okay. And he noticed that during this transient, the sudden change of the switch is actually causing the change of the current. So I made a comment, just to repeat it, comment that we are this close to use a flyback, but the flyback is not a transformer. It is you see, the people in the flyback assume if a flyback converter can step up and step down, and it's isolation. Step up and step down in input voltage. Well, that's what this circuit does without the diode on the secondary, right? It can kill an elephant, you know, with this kind of thing. One turn of primary, 1,000 turns of secondary will make 100-volt DC battery, make it in 10,000 volt and kill them elephant, right? But that's a transient feature and not the real transformer. So transformer having DC, having ability to step up and step down, and having ability to, provide isolation, which is currently have, because it's in, there are no electrical connection on primary and secondary ground. So isolation and
step up and step down feature is not enough for a transformer. For a transformer to be a transformer, and I have another lecture, then we can go that if you have time, but which says the transformer has to be such that, like an AC transformer. The magic of AC transformer is because it's driven by not by DC but alternating current, it automatically provides how I say high magnetized current and alternating current on a secondary. But the point is that transformer does not store the energy. Secondary current is reflected to the primary, subtracted from the input current, and the difference between input current and output current is a very small magnetizing current, which is an AC current. So I'll give you another of my experience, how backward is this whole power electronics. I had battled for years with a Plexim company, which I used their software for many years, since 2016 or so. And I was advising them, please don't confuse the people and don't give them a model of transformer with a turns ratio only. That's stupid. You understand why? Because a transformer, which has a, and they provide a turns ratio as a model of perfect transformer. Okay, perfect transformer. It doesn't include leakage inductance. Fine, I'll buy that, even though that's stupid because you have to include the leakage inductance. But the problem is, when I tell them, when you use only turns ratio for a transformer, what you are doing, you are in your software, you are reflecting secondary side to the primary side, but doesn't tell you whether that quote transformer has an AC current. We got rid of Crowfoot. Okay, great. Thank you very much. Okay, I didn't have to mute him. I just removed him. All right. So that means Zoom is working. I can now, from now on, use that. And whenever we see someone intruding like that, we just kick him out. Okay. Getting back to the transformer. So what that says is that the key property of a transformer is that it doesn't store energy. And I told them for years, please don't give the stupid turns ratio of a transformer without including an inductance in the primary side. Then what will happen? When you do simulation with a program, then you look what is the current on that inductance. If that current is an AC current and no DC current in it, that is a transformer. If it is not and it has a DC bias on it, it's a bullshit like a flyback converter, okay? And I say that with a conviction that the flyback transformer is the worst thing what happened to switching converters. Why? Because it is a same thing, like what is the difference? Buck inductor is not inductor, as I showed in other presentation. It is a fake inductor because it is inductor, because the filter on the output, LC filter, that inductor conducts all the DC current to the output. So therefore, that cannot be made as an AC inductor. It's a DC inductor with the bias, which means you have to put air gap, and then instead of a magnetic core doing something, it's not doing anything, and basically becomes a short, and you will actually like the short unless you put an air gap. So that's the point I'm making is the whole, and of course, why is the flyback magic that the people think it's a magic? Because flyback has boost converter, has input inductor connected the input DC source. Buck has a output inductor connected to the output DC. Flyback has a inductor, non-isolated flyback has inductor connected to the ground. Okay? So if it is connected to the ground, you split it into two windings, and flyback is two winding inductor. Where you store energy in an inductor on a primary with the input switch, and when the input switch turns off, stored energy in inductor is through the secondary inductor
transfer to the output. And because this inductor is with one way connected to ground, you break a ground conduction and you call that isolation. Yes, but it's not a transformer. It does isolation, that step up and step down, but it's not a transformer. It is energy storage device. And I get long discussions with a professor, whatever, Ben Yakov. He's extolling these things, and I was putting all over. And on YouTube, a lot of people jump on it, and he's great. He understands nothing. He's just he's got, I don't know, 20,000 people following him, which is a disgrace because he's giving them a wrong impression. What is a transformer? He's going, flyback it's a transformer isolation and so on. But they don't understand what a transformer is. The same thing, the people who are doing this simulation software program Plex, they couldn't buy a very simple thing what I suggested them. There are other problems with it. When we're chased in my future lectures, I'll tell them about you, I'll share that, and I'll teach you how to use Plex software such that you can really, instead of getting long time simulation of 5-6 minutes, and then at the end it says doesn't converge. I'll give you one which with the use of my state space averaging, which I'll teach you in a course. You can actually give an initial condition which are just right. DC levels on inductors and DC voltage on capacitor as starting point. Then in a section of second, like 100 milliseconds and so on, you'll get results, and you get correct results. Okay, so the whole thing is polluted with the nonsense, and which I'm trying to solve, and hopefully you can be the generation who does that. Okay, I'm glad we got rid of this guy, so at least we can continue. So let's go further. So I told you here what is important is if this is a transformer, you have to have inductance as a physical inductance, and then get simulation result to show you what is the current. If that current has no zero average, forget it. It's not a transformer. It is flyback nonsense. Okay. All right, let's go further. In the output. So this is a verse of his law of electromagnetic induction. You have to have change of the current, which results in the change of the flux, which result in induced voltage on a primary and induced voltage on a secondary. So you could see on a secondary change of voltage. Okay. Now, also at that time, you would be able to use turns on a transformer and use a turns ratio. So if you use a turns ratio of 100 to 1 from primary to secondary, if you use DC source on input and you switch it on and off during on and off period, you would induce the high voltage by a factor of 100 to 1 on a secondary compared to primary. Well, if you wanted to zap someone or kill, you could do that, all right? But it was not sustaining current. It was not continuous. It was not permanent. And in fact, for next 50 years, the whole world gave up on that because they considered this alternating current as useless because, let's face it, if you have sinusoidal current, you have positive, it will force the motor to go in one direction, and if you have negative part of sinusoidal current, it will drive the motor in the other direction, which means it won't move. So you needed to rectify it. So everybody was making the generators, DC generator, by rectifying internally generated AC current and AC voltage, rectifying it, and externally shows a DC voltage and DC current using complex commutators and mechanical commuters, which are rectifier. Of course, the Tesla was first time in 1882 to some 51 years after Faraday realized that there is two processes happening which are reversible, that every machine could be used as an AC generator as well as AC motor. And you can convert mechanical power into electrical power generators, and therefore, for the first time, you were able to drive the same setup that Faraday had.
transformer with big primary, big secondary, big core of iron, which is magnetic material with high permeability, and you could actually drive it and use it as a source of transmitting higher voltages on. It makes a comment. You see to make it simple, I made a point here that is actually not correct. I made a point that you have sinusoidal voltage on a primary, you have turns ratio transformer at whatever 60 hertz, and then you have motor on a secondary. No, what I showed is just conceptually what you need at the minimum, which Tesla showed by introducing so-called polyphase voltages and polyphase current. You need at least two-phase AC voltages 90 degrees out of phase to provide rotating magnetic field. And then if you have synchronous motor has a two-phase winding on a stator, and have a magnet, permanent magnet in the center, and a permanent magnet will follow whatever this rotating field is, so you can control the speed. That's what is basically how the electric cars works now with the Tesla motor in it. But you need at least two-phase input, and you get two-phase output. However, yes, you don't need, and that is reversible, because that motor can actually work backwards as a generator. Although some of the motors are, like induction motor, is optimized as a motor, and it's lousy as a generator, you know. And the same, then a problem with the synchronous motor and synchronous generator, that you have to bring it up to synchronism to do it. So anyway, my point is that then people are making these days comments and say, oh, well, you know, you can, way before the Tesla, people realized that you can use alternating current to drive. If this is not motor, if this is a resistor, and if the resistor is instead the lamp, which is a Edison lamp. Edison was driving their lamp with DC, but there is no reason why you couldn't drive a lamp with AC. And in fact, before Tesla invented rotating magnetic field and motors and generators and polyphase current and high voltage distribution and so on, some people suggested and say, hey, we can use what looks like a transformer as a single phase transformer driving the lamp. And yes, they did that. But they're not really inventors of the transformer in a true sense, because this one is just by definition when it is a resistor, and this is a dot connection. So that means the resistor will have a current drawing from a dot and driving the voltage into resistor. Current is getting out of the dot, but reflected that current on a primary is current into the dot. And this current is out of the dot. That's meaning of the dot connection. What that means is that, yes, the reflected secondary resistive current is reflected to the primary, and the input current is larger by magnetizing current of a transformer, which is very small. So therefore, the beauty of a transformer for a transfer driving the lamp and so on, that indeed in a single phase transformer, you essentially have a magnetizing current, which is different. Then you don't need all these other things, Lenz's law, blah, 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 because here it is all done automatically with the dot connection. So therefore, and the beauty of a transformer is, and that's why I'm driving now when we get to my concluding remarks, I'm driving that the beauty of a transformer is that 60 hertz transformer has everything into it. By driving it with the AC voltage, everything is done automatically. Forget about Lenz's law and so on. You're driving the resistor, that's fine. Now, different story. If you drive the motor and motor has inductance, then you can't do that, you know, and you have to drive it with a two-phase winding on a stator and a generator, two-phase generator, and then drive two-phase induction motor, you know. So that's the beauty of it. But the point is that I'm making now, what is needed, and let me give you the driving point, which I came to the conclusion after so many years working in this field. I don't want to waste your time now because we don't have it, but in my detailed lecture, I will show you how I went through at least 4 or 5 different ways for making new transformer for high frequency. My Chuk converter was having instead of sine wave voltage driving it, it's square wave.
And like square wave is average. Average is 0. So like a sine wave has a 0 voltage, like sine wave has a volt-second balance. So yes, when I have my true converter volt-second balance, but what is needed? This one here, as I said, when a resistor is here, it has a charge balance automatically, 60 hertz, no switches, nothing, but automatically the current drawn into the resistive load reflected on a primary, and you have a charge balance. You understand? So the transformer can make a large magnetizing inductance and single phase transformer charge balance. Now, if you want to make a DC to DC converter, what that means, with isolation, galvanic isolation and no storage, then what you need to do is have a converter topology with DC voltage on the input, draws the DC current from the input, and DC voltage on the output draws the DC current to the output. What that means, that input power in that DC, magic DC to DC converter, fancy, has a constant input power and the same constant output power. The only difference is this small magnetizing current, which is 1% of the power. You see what I'm saying? So basically, we have in a DC to transformer, we have a built-in volt-second balance on the primary and charge balance between primary and secondary, right? And when I invented the true converter, I made a converter which is driven by square wave voltage and delivers square wave current on the output. But then the magnetizing current on the input has a square wave voltage. What is square wave voltage going to do with large magnetizing inductance? Make triangular small ripple current. That's the only difference. And that transformer has the same property that you have it satisfies because I had input and output inductances and capacitor on both sides. Then I made artificially that square wave voltage on the input is drawn square wave current on the input, and square wave voltage on the output, square wave current on the output. So basically input power and output power is constant, and the difference is small circulating current and power stored in magnetizing inductance, which is near. Magnetizing inductance doesn't store power. It just changes from positive to negative flux, so therefore it's just returning back. So it's what I'm trying to say is you need to make a converter such that if you want to do DC to DC conversion, this did it, square wave, and in fact my true converter did it not only for square wave because it had capacitance on input and basically had volt-second balance on a primary and secondary by that definition, and it had a inductance on output, inductance on input, had a DC current transformation and no storage. But what was problem, because it had square wave voltage and follow with the square wave current, in the transition, you have a voltage dropping to 0, current coming from 0 to peak DC current. So in that small transition, you have a big pulse of transient pulse of energy stored in a transition, right? So what happened is if you have a high frequency, the high frequency, you multiply the energy storage in the transition to the basically energy storage in the transition is lost in power. In other words, power loss per cycle times the frequency of that. So it's proportional to frequency, horrible. And that's even not accounting the leakage inductance, which is the special factor. But now I'll teach you in this course this magic, what I call a PWM resonant converter, which looks like a resonant converter, smells like a resonant, but it's actually a regulated pulse width modulation. And what is the magic of it is that basically then you have to make sure that the transitions are lossless. So how do you get that? Zero voltage switching on input 2 transistors or 4 transistors, active switches, and zero current switching on the output secondary side with the diode. Great. And what happened at the same time? No energy storage and leakage inductance. 99% efficiency, right? So that's what I'm saying, you know. But now I graduate to another point where I can make now that transformer not proportional to the frequency, but by the topology, connection and structure, make it much less even at the 50 kilohertz or 100 kilohertz switching. because then you minimize all the losses, conduction losses, and so on, and you don't have any losses due to the lousy transformer, and eliminate storage, storage on leakage inductance, eliminate storage on input and output switches, and then in fact still have control by controlling duty ratio of the input switches to provide a high frequency isolation with no storage and 99% efficiency. Anyway, let's move further because we don't have time much. So
It's a continuous periodic drive on it. Of course, in between 1831 until 1882, there were Pixie and some other who actually determined, yeah, you can drive this primary with the alternating voltage they can generate it. And guess what? Edison light bulb is just a resistor. So you can put on a second Edison light bulb and power it for lighting. So there was some effort in between to make a lighting using alternating single phase, of course. But the first time when Tesla demonstrated after 1882, in 1893, he demonstrated the first transmission of the power from Niagara Falls, where he had generators and mechanical energy is converted into his synchronous three-phase generators. And then that power from few hundred volts is transferred with a transformer, which are using as a step up to high voltage. Then he had a high voltage three-phase transmission link to Buffalo, which is 26 miles away. Why? Because they needed tens of thousands of current there to convert bauxite into the aluminum with electrolysis. So I need a lot of currents at the volt. And then, of course, there you transform in opposite direction and go from high voltage transmission line down to the low voltage DC.
Okay, my comment to this, I'm not having a time to do that, but since you have access to my YouTube lectures, one of the lectures is my lecture long time ago, when I was 43 or something, with Hughes aircraft, you know, and I demonstrated, I have also demonstrations for a rotating magnetic field. And here is a contraption two ways. One is that there is a toroidal transformer, which operates at 60 hertz. And inside that is, of course, there's a two-phase windings on it, and generated by this AC input power, and I use the capacitance to phase shift it to generate the second phase. So anyway, this contraption below, which I have, is to generate for this two-phase winding of the structure, which is actually really four windings on one side, one phase, and two windings on the other side, and therefore generate a rotating magnetic field. But this rotating magnetic field operates on the leakage of this transfer, not on the main flux. But nevertheless, you can put here the metal aluminum mag, what we did, believe it or not, at 60 hertz. It was not getting a synchronous speed of 3,600 RPM, but it's getting around 1,800 RPM. I mean, it's like a huge power. So I had actually to put something over it. So you can watch, you can watch my demonstration, one of these on my YouTube channel. And in fact, I made also a very simple demonstration of a 750 horsepower motor, where I pulled out this. You see here, this is a big squirrel cage rotor, which is shorter turns and which served as an induction motor rotor. But the point is, when you pull out this rotor, your inductance becomes, 100 times smaller. But that's why I had to make this with a box which reduces 110 volts two-phase to the 10 volts two-phase, which means 10 times square, 100 times lower force. But that's okay, because that way make sure that if I put a Coke can, which is really
example of this short return as a secondary, then you still rotate at the synchronous speed, but it will not burn a winding because I reduced 100 times the current in a primary, okay, or 10 times, whatever. So anyway, you can look at that. That's a point of demonstration of Tesla using a toroidal core, big toroidal core, and his famous experiment of rotating rotating magnetic field, rotating this aluminum leg. Okay, so let's go further.
And the point I'm making is in just 10 years, 11, from 1882 till 1893, the first system of electrical distribution was set up. And really, interesting point is, which I think is, so they basically, in 10 years, he already demonstrated, and it's what in Chicago Fair, there was 1895, the big fair, and there was decision made where they're going to use to have all this lighting done using Edison DC or alternate current, and decision was made alternate current was much better, and therefore the Tesla and Westinghouse got contracts, so they lighted 1895 the fair. Now,
yeah, the World Fair in Chicago was the first big demonstration of a Tesla polyphase system, and he actually used it to this World Fair has a huge lighting, and then a transformer of his. Of course, there was a two-phase transformer or a three-phase transformer. In fact, three-phase was used to provide lighting for a lamp. So he demonstrated in a big way how his three-phase power can, how to say, light up the world. Now, talking about this, let me just mention one other thing. You know what we're doing nowadays with the lighting? There's a beautiful, beautiful, absolutely gorgeous invention made by three Japanese two professors and one engineer. They got a Nobel Prize for inventing gallium nitride LED, which is capable of doing what regular silicon was able to do it now for a red light and green light. But the problem was how to make a blue light. And this guy who was in Japan, he said, "Oh, I'll do gallium nitride instead of silicon and do the blue light." He was successful in that. But what is the problem with the? And then of course you have a blue light, then you have a green, blue, and red. And what do you get? You have white light, beautiful. But what's the problem? How to drive that lamp, LED, blue LED? You have a 100-watt converter, which is this big, and you are driving it, the little thing, which is very efficient, but now the converter is 10 times bigger than it should be, 10 times more losses, which is 100 times more work. So that's why we have a problem with how to drive LEDs. And then, by the way, one of my recent inventions that I'm pointing out and so on is showing how we can make the transformer and a converter which drives LEDs, and it is as small and as efficient as LEDs. Because what's a useful step? To drive LEDs, you need something 10 times bigger and times more losses than LED, right? Anyway, let's continue further. I think, whereas I have some other point to make further. Yeah, here. The point I'm making it, you will hear in my course, that was 2021. That's the last time that I did in-person 3 days course at UC Irvine. And then since that time, I started doing this online courses. And I made this really demonstration of say, it's about time we really retire buck, boost, flyback, and forward converter, because forward converter has a half good transformer, but AC transformer, but has output inductor, which is again limiting the current and the power they can deliver to that. So it becomes a limitation for whole power electronics. So how we can make a electric drive for cars and put a 100 kilowatt charger inside the electric car, which is no bigger than induction motor, which is being driven there, if you use the present technology. So what they do, present technology has a driver to the EV car is as big as a car itself, and it's sitting 300 miles away at some place, and it's costs $100,000 or more because we don't know how to build how to build a charger as small as an induction motor, which is inside that has 100 kilowatt, 150 kilowatt AC motor, and then you have a even drive is on the size of the motor, but the charger is 10 times bigger, 10 times more expensive, and 10 times more losses.
You know, Nobel prizes are.
Okay,
you know,
so I think now we have to. What I want to do is, okay, here.
Switches, semiconductor switches. We can switch very fast. We have putting the AC system in place. First time we can actually, for first time, consider, can we actually take advantage of high frequency, but not what the people at Tesla and Faraday thought. Maybe we should generator, and Tesla was able to do it, to make a 400 hertz voltage. In fact, on a chipboard is used 400 hertz alternating current is used, and voltage is used to reduce dramatically 10 times size of generators and size of the motor, because they need to be there on a boat where every pound costs. And of course, now we have electrical car, which don't use even 400 hertz. They only use 1.6 kilohertz, believe it or not, frequency the motor, and only increase from 60 hertz to 1.6 kilohertz. Yet we are switching now at megahertz, and yet we are not getting a return. Still, we are not. If you say now we are at 60 kilohertz switching compared to 60 hertz, that's 1,000 times higher frequency. And you would think, okay, we could make the sizes of magnetics, the sizes of transformers, 1,000 times smaller. Not so. And we're doing something wrong. And there is a better way around the corner that we should be able to take advantage to indeed make a much smaller size of magnetics and make a not alternating, but high voltage DC transmission line. And now hopefully by the end have a chance to a little bit talk about that as well.
Okay, time to switch to my other presentation, which was, how to say, here. Let's look at my other presentation, which is here. Which is also, by the way, this is what I added. This is a more complete presentation of which will. You can see it now. This is a basic review of what I just told you. By the way, did anybody have these 4-volume books? Yes or no? Who has purchased these 4-volume books? No? 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 Well, you're missing. I published this
1,200 pages with my research group at Caltech and Professor Middlebrook, who was my mentor at the time, and afterward we were working together. And volume 1 is now what used to be volume 2 paperback edition. It's volume 1, and it was later. Then volume 2 is published papers between 81 to 83. So by 1983, which is I finished PhD at Caltech from 74 to 76. So 5, 6, 7 years after my thesis. Then volume 4 is my PhD thesis, which is a basis for all of this, which I followed after that. And volume 3 is a bunch of the practical design articles and applications and so on. So it's 1,200 pages. I published it as a 4-volume books on Amazon, and Amazon, sell them $100 a piece. I tried them to sell them as a package, but they wouldn't do it. Because of that, I said, okay, you can now buy directly from my website, tesla.com, and you order it, and I'll send all 4 of you at a much lower price than when you order it from Tesla or then through Amazon, because they wouldn't agree to send it as a package. Okay, that's a little description of how I was ahead. Now, what is this? Cold spell and storm in Texas, because some would think that's why I engineered that, so we can show how the electrical power distribution throughout the world is important, and we cannot live without it. Okay, and for nuclear power plants, tribute to Nikola Tesla, that in just in this lecture, and Galvani and Volt actually, okay, and he found out, yeah, Faraday, who was then already at to anything, but using it, and he made a here, which resolves. What's happening? I thought you have positive. Sorry, it looks like we clicked on the wrong thing. Clicked on this one instead of that one. Sorry. Yeah. Sorry for this question. Let's start the show, and let's see how the people will fix it, or along the way make it happen. Okay, let me tell you also how I want to conduct this, because there are so many people. I would like to make a presentation with a minimal interruption, and you can use the chat to ask the question. Some people are already doing that, and one fellow said his cam is broken, the other, so you can use the chat to ask the question, so you're not interaction. Hopefully by that time you'll figure out how to make sure that your video works and your audio works on your computer. If your computer works, I suggest one thing. If you all have a cell phone, get connected on this meeting on a cell phone, because every cell phone now has audio and video which works automatically. Okay, so that's the point. Speaker view, and when I'm in a speaker view, you can see me talking, and then whoever actually gets to interact and talk, he will also show on a speaker. So I froze a picture for a second. This is a okay. Let me to speed up because you're going to get a copy of this embedded in my presentation. And this time there is also another experiment which is available on YouTube channel. I don't know where I picked it up, but embedded in my presentation. And what it is a recreation of the famous experiment that Ørsted, who was Danish professor in Denmark, who made a lecture in 1821 when everybody was trying to establish connection with electricity and magnetism. And I'll just tell you briefly, which is already said in this one, what he did is he made a lecture in front of the audience, and you can see this, this here is the battery which generates this DC current, DC battery which generates DC current in this red wire. And you see what happens there,
he put a magnetic needle next to this DC current carrying wire to establish, can the DC current generate, let's say, DC magnetic field and affect magnetic needle? And in his presentation, he was not successful. He was actually trying to demonstrate that it doesn't have connection, that the DC current cannot move magnetic needle. And in fact, it didn't until what? Until some guy, smart guy in the audience, or very often audience is smarter than a lecturer, right? So what happened is in a break, one guy from the audience say, hey, why don't you make this current and reverse, just put below the magnetic needle, put the current to go, instead of this way, go in opposite direction. And what happened? Magnetic needle jumped all over the place. Why? Because magnetic needle responds to magnetic poles of Earth, north-south pole. That's how the navigation was done with the magnet needle, to tell whether you're moving north or south and so on. And the reason why the first time it didn't work, because this force that generated with this current in that direction was generating in the same direction as a magnetic force. So it actually very little changed, so there was no interaction. But the moment you change the current and it's going in a different direction, then there was a big inclination. There was a huge surprise in the whole world, and that started that started Ampere to develop Ampere circuit law to describe what kind of force is made on this needle and so on, because it was constant current generating a certain force, and then it depends on how far it is from a current, because further away there will be less force. Okay, so establish connection, and then for next 10 years, from 21 to 31, until Faraday invented law of electromagnetic induction, everybody was trying to do that, to conduct the DC current and generate force on magnetic needle. And then they said opposite. If I get a magnetic force by permanent magnet, I should be able to use permanent magnet and generate a DC current. So you don't have to use volta battery. We can generate the generator. This is generator from magnetic permanent magnet. Of course, it doesn't work, because who was actually who proved, picked up from an internet short video, like let me see how do I want to jumpstart this, but it doesn't let me. Showing the very important experiment which was done way back in 200 years ago, actually, to be exact, wow, to 201 years. And he made an experiment trying to prove, wait a minute, that electricity and magnetism the problem are not connected. I realize now the problem is, so what he was, when I have this embedded other video, I cannot run over it, it has to, how you say, trying to prove and get an actual demonstration. Well, I don't know. Because at that time, 10 years prior to that, is Galvani discovered this, live electricity by cutting the probes, and then later the Volta figured out how to make out of that. We're talking about Faraday. Okay. And I'm saying that Faraday, I found a way how to jump. Okay. So this is a later part of the go to demonstration. 1821. When he heard 1820, when he heard at Faraday experiment, everybody tried to do the opposite. Well, it makes sense, right? You have a constant current going and affecting magnetic needle. And then the thought was, can we do reverse and put a magnetic field? And there was at that time available permanent magnet. You can get magnetic material, which is a permanent magnet.
and you use a permanent magnet and say, okay, I'll put a now permanent magnet around the wire, and I try to generate the DC current. Well, the only problem is it doesn't work, even though the Faraday spent from 1821 to 1831 trying to prove just that. And what has happened, as you see here, he concocted this experiment. He's trying to repeat exactly that. He put a battery, because that was the only source of the power at that time. So he put a battery and put a switch in it, and with the idea he'll turn on the switch, and we'll get now on this what it looks like. It looks like and feels like a transformer, except it doesn't work like a transformer, you know. And I explain in a second. And the system he had is he had at that time very sensitive galvanometer, which could measure milliamps of the current. And then when you would turn a switch on a primary, this whole gadget, and you can see it in a display, the original transformer is a huge toroid. And he put a one winding on one side, one on that room, and he put this battery source of the power and the switch in one room, and then the toroid and galvanometer measuring in the other room. And he would initially spend a futile attempt trying to turn on the DC power and get a DC power on the output of his transformer, right? But it didn't happen. Why? Because he would come and turn a switch on in one room where this concoction was on the left-hand side on a primary is in one room, go to another room and wouldn't see anything. Until one day, I guess his assistant was again, how you say, by a mistake, came early. So he told the assistant, turn the switch on, and he was working in his room. And guess what? Just during that instance, when you turn the switch on, there was a declination of a recorded current, transient current in a galvanometer, right? And then, so as you turn the switch off, again, there is declination in the other direction. So that's where he discovered the law of electromagnetic induction. And the people start seeing they can make an electromagnet if you put a magnetic core, and which dramatically increase the flux in the core and force. Then with a small current, you can pull out big, attract the steel and move it from one place to another. But the point, they were all stuck at that time that you need a change of the current. And he introduced his Faraday law, but it was waited until later in 1860 something, 67 is when Faraday died. But before Faraday died, Maxwell came and explained why it is impossible. And of course, he came along the way with the Maxwell equation, why it is impossible that a constant current operate in this gadget. It is only it can only operate in this transient mode. And of course, what happened in the meantime, I think there are some people who realized, well, if that is the case, they tried to make a, how to say, transformer to operate not with a battery, but operate with the alternating generator, single phase generator. And then it turns out if you put, instead of a galvanometer, we put a light bulb will shine, because then Tesla proved his in 1882 that it's just the opposite. One thing I wonder, and that's unfortunately with the whole world, I wonder if Faraday and Tesla were alive when Faraday and Maxwell were alive and Tesla did that. I'm sure they will give us sum up and say this is the greatest invention since sliced bread. Unfortunately, after they died, there was nobody of that stature to really back that up. And then there was a big war of current, whether we should use a DC for a transmission or AC. And the funny thing is, nowadays, we have all the tools in the power electronics to make it happen, to make a DC high voltage transmission, but not the way they're doing it now, but using it as a high voltage transmission, because right now what they do is they are still stuck with an alternating current, and they use the alternating current at high voltage to convert it to high voltage DC, and use a high voltage DC cable, because that's you can put underwater and connect one island to another island in British Islands, and then on the other end in the island convert it back from DC to AC. But that's not a point. Now we can make a use of this beautiful device transformer, especially even for a single phase. We can make a DC to DC conversion high voltage, which is initially using the source of power, not like Niagara power plant with the converting the mechanical power with the generators, 60-foot generators in AC power, but use the sunlight, which comes naturally to DC, and use a converter to transfer it with the isolation to transfer it to very high voltage from the primary.
I'm now
You are
jumping,
going to
I'm now jumping another 20 minutes, and you can review all this eventually because it's on this link, on the same link. But I just jumped to AC transformer 60 hertz in 1882, where he basically made a single phase primary and driving the battery, and AC voltage and AC current at 60 hertz, and 200 volts in US, 110 in Europe, 110 in Europe, and so on. But one thing I want to make sure, what we people at this time, Tesla need a mechanical power to transfer to electrical power. By inventing his three-phase generator and putting it in Niagara Falls, he was transferring the mechanical, huge mechanical power, which is on a megawatts level, from a Niagara Falls to generate with his three-phase generator power. And in fact, they would actually, I would say, during the day, they would let Niagara Falls show its beauty for visitors, but at night, they would channel all the power, all the, I say, waterfalls through tubes to drive his three-phase generator. So there will be no thing to visit and see the waterfalls at night, because they're converting power to Niagara Falls mechanical power of water to electricity. And then where was the first time he used his high voltage transmission line? It was used from Niagara Falls to the nearby Buffalo. They had a big big plan to use electrolysis to generate, I would say, to extract aluminum from bauxite, from this ore. And it requires a very low voltage, but huge current. But that was not possible to create and transmit 42 miles away to Buffalo. So they used the first high voltage transmission to do that. And that is a mechanical power, understand, mechanical power converted to electrical power. And then he used high voltage transmission lines to transmit it to the long distances, and then transformer backwards, three-phase transformer backwards, to transmit it to the regular low voltage where you can drive the motors and so on. But what's the difference between then and now? We have solar power. And solar power is a source. We don't need mechanical energy to transfer and generate electrical power. We can have solar power. But solar power is DC, you understand? And because it's DC, then there's only one remaining problem. How do you make efficient DC to DC high voltage conversion? How do you generate from 3 volts, 2 to 3 volt solar cells and put them in low voltage high current in parallel to generate low voltage high current source, and then use a really beautiful transformer at 20 kilohertz or 50 kilohertz, transmit it to first 400 volts DC. But once you get 400 volt DC, use the same system to convert 400 volt DC to 4,000 volts. Okay, and proportional low current. But once you have that, what is the next step? You can have a 10 secondary turns and a stack voltages of 4,000 volts 10 times, you get 40,000 volts, right? And what do you have on a primary? You still have 400 volt devices, you know, right? And 400 volt and appropriate higher current, single primary, and you have a power on 40,000 volts on a secondary. Now you can have ability to use a generation of the DC power directly from a source of solar cells. You don't need mechanical power. But once you have that high voltage DC, you use this DC to DC converter backwards to go from 40,000 volts down to 400 volts and distribute 400 volts DC. The only thing which is missing in that thing, and I still didn't come up with that, I think that requires it has a nice AC voltage source, which is solar cells, DC voltage source, solar cell, but it's missing the DC, nice direct DC motor, right? Because DC motor exists, but it is really concoction because it has a mechanically it's very bad because it has a how you say rectifiers and commutation and all that stuff, which Tesla noticed was bad. So it'd be nice if someone, and I give you that, tried to invent some direct conversion of DC voltage, high voltage to 40,000 volts to 400 volts, and then have a 400 volts motor, but to be more like a real like Tesla induction motor, except Tesla induction motor requires the AC three-phase AC windings and to operate. So anyway, but in any case, this is where the future is, because advantage of this higher, let's say, advantage of the solar cells, we don't need, as I described, we don't need for that ideal DC transformer, we don't need, I say, the energy storage. It's not stored. Give you an idea. Could that be applied? If you provided you have that kind of ideal transformer, you have a transformer which is driven by DC voltage on input and sources DC current, clear DC current, and then have a galvanically isolated transformer which has no storage in the leakage inductance, has no problems, has a proportionally no switching losses on a primary and secondary, zero voltage switching on primary, zero current saturation on secondary, and therefore you have a very high voltage step up converter which doesn't store energy. Now, what about feeding that? Well, give you an example. You know, you heard for the Trans-Siberian Railroad, it goes from St. Petersburg on the East Coast, on a West Coast or in Russia, and they have a train which goes 2 or 3 days all the way to Kamchatka, which is some, I don't know, 10,000 miles or so. And is there a train there? So if you have a train there and there are tracks, so all you need to do is put between the tracks, dig a 1 meter deep and put your DC transmission cable, which will be having this positive DC, negative DC, and neutral, and buried in between how I say between the tracks. And of course, every 100 miles, what do? You put a solar panel, and the solar panel provides the DC low voltage power, and then with this transmission line is converted to high voltage, and of course, if you convert it to 400 volts first,
You can use 400 volts to drive the train, itself without how to say, diesel or other things driving the train. But at the same time, you feed the power every 100 miles into this transmission line, which is 40,000 volts. So how good is that? Well, terrific. As the sun goes around, you're creating the power they needed. So you're pumping the DC power at high voltage all along as the sun moves around. How good is that? Well, that's the future. That's what is actually what I'm working now and what is possible. And hopefully, if you stick with me for a few years, you'll get to learn about it. Now, let me get back to the course and what we are expecting next. I already introduced you. You will get all this. It looks like more like it is like 2 hours of my presentation so far, and you'll get a copy of this link to this, so you can look at it and read it at ease. I will, in the meantime, send you some more information which will be uploaded on my Academy 23 folder, and hopefully this will give us enough time to, as I alluded to, essentially promote that my new course, which will be based on Academy Power Electronics Academy, posted on Facebook, and having everybody sign up on WhatsApp, and I will actually have everybody who was in my past online courses and my past offline courses, which are in-house courses, to join and make continuous education. I do plan to use at least once a year to make this kind of a lecture, which last time I gave a six weeks lecture. This time I will be planning 8 weeks lectures with everybody connected on WhatsApp, and then I have lots of things now to upload additional material on my Academy 23, and between now and I hope within a 1 month or around, I'll keep you updated. I'll get through the current problem with this as I'm establishing new from my new bank and their I would say payment service, not to get this fraud and hacking will happen so far. And I will revitalize my both of my websites and then establish the presence on Facebook. So just be looking into the future, and hopefully maybe some of you might be interesting to join in my journey to really create future power electronics, but not in the 22nd century, but really now, because the time is available ripe now, because we have all components to do it, but we didn't have a right system to actually implement this high voltage DC generation and transmission. We do have an infinite source of energy in the solar cells, but we don't, and where can we implement it at a grand scale, like I mentioned one. Of course, we could do also the cable underneath the Atlantic, and instead of transferring the signals, we could have transferring the power, and therefore not being stuck with this high voltage transmission line, which are really sore because danger to when we have all these hurricanes, which is just happening in Hawaii. This whole Hawaii disaster was they're still hiding it, but I think at this present I think there's probably several thousand people who have burned to death. And you know why? Because the fire was generated because of a high voltage transmission line. When they break due to the wind and everything else, then they cause a short, and the short causes a fire. And the fire overnight, and they had a warning system in Hawaii, which was intended not for a fire, because they considered that a minor problem. They were designed and have a fantastic alarm system all over the place if there is a pending tsunami. So if some people were, if there is a big waves coming, so they had the sirens and everything else to warn the people that there is a tsunami. And then the guy who was in charge of that, he decided not to use it to alarm a fire when the fire started in the mountains there, and then moved fast, and obliterated the whole. Initially there were 100 people who died, but only five of them had been confirmed who they are, because most of them burned completely to death. What's left of their teeth, and now they're talking about 1,000, 2,000 people, which died with nothing left of them, And why? Because this guy was smart enough, and instead of turning that alarm for a fire as well, he said, oh, he was afraid if he turned it on, people will run into mountains. What a stupid thing. Why would they run into a mountain when the fire originated? You know what I'm saying? Because he thought tsunami will say run away from a beach and then go to mountains. Hey, people are seeing a fire, but they have to be woken in the morning when they're sleeping, So people are stupid, right? Okay, that's the point. All right. And unfortunately, our field is going backwards, as far as I'm concerned, in the last 20 to 30 years, with the gazillion publications, which are just cluttering the whole field with a bunch of nonsense. Okay, so hopefully you'll stick with me, and you will actually carry the words to your colleagues and friends to join as soon as I get my website going back, and my registration to the courses, and then we'll start this course in as fast as I can fix all of this happening, and expect a lot of learning, and you can really learn it. I'm glad whoever didn't get so far, and I complained to me if you didn't get access to the Academy 23, I'll send you immediately a connection, so we'll go from there. Okay, so
Sorry, can I just ask a question?
what is that?
I'm sorry, I didn't understand. So the course isn't starting yet. It's postponed.
As I said, I have still problems because they hacked my website, and they have my registration and so on. So I'm working around the clock to establish that as soon as possible. I hope a couple of weeks. And in this transition period, I want to make sure that everybody has access to Academy 23, and go look at some of the stuff they're going to upload there, including this presentation. Go to my YouTube, because you have already access to these 2 lectures. And once you go to YouTube, you'll have access to the bunch of other 50 or so lectures that I did make from previous 2 online courses, and as well lectures that I made from previous in-person courses at the UC Irvine. So there's a lot of material to learn, and go for it. And I will update you as soon as possible. I might, in the next couple of weeks and so on, invite you for another, I would call a presentation, which I will make it like a free website to invite your colleague to do some critical discussion. For example, explain why the present power electronics is on a wrong track because of this, what I call it, fake conductors, and how we should go and forget about what the present switching converters are, and except for pointing what's bad with them, and then how do we go and avoid the current situation that most people are totally uneducated in magnetics, don't understand magnetics, and they propagate their complete misunderstanding of it. And then hopefully when you go through this whole course of which we now, instead of 6 weeks, it'll be 8 weeks, then you'll be much better off, and then you will join this what I call a revolution, which is about to take place. So thanks very much for attending and so on. And I will, after this, I will send you links to this presentation. I skipped a bunch of the parts because it's too long, so we can have here, and I have here on a chat. I can include what's on the chat. Is that what it is? Okay. No, I'm just trying to see if I can get this. Going to have a huge inductance when you have this core, and a huge inductance will say that the current. Okay. Anyway, all right, guys. I think today we have also been on a learning curve how to eliminate the unwanted guys who are, just evil in what they're doing. And you see here on my website, now I learned how the modern, presentation like a YouTube and so on that I have, it is now not only giving you the, text of what I'm saying, translate title, anything of what I'm talking is translated into text, so you can watch and listen. But also it has this here, you see key moments, so I was able to jump. And for you, if you want to review, you can jump from one thing to another, electromagnetic induction, Maxwell equations, Faraday's law, charge balance, and so on. Okay, so at least you now learn how to navigate. I learned how to essentially get some of the intruders who are just wild hucksters, to get rid of them, which is very important to me, because then I think I can avoid what I did before. It will take half an hour or 1 hour when I get 40 people or 50 or 100 people, that each one joins, and usually people don't come on time, so it's constantly interrupting my presentation to accept another guy who is coming on. This way, we keep it that way. If you have this link that you have over internet, you can join. If you're late, you can join. You can join with audio or video and whatever. And then I have now ability to, when we find out where the source of problem is, we can not only mute him, but we can actually drop him out of the presentation. Okay. Thank you very much, guys. And I'll expect to see soon from me this link to the presentation. You're welcome to join my YouTube, because you already have access to these two YouTube presentations. You will see a lot of lectures on what I did in online to my previous two online courses, as well as previous in-person courses. So have a great day, and sorry for this delay, but I live in a present situation like you do, where there are a lot of bad things happening, and even institutions like IEEE are not educating people, but they're just trying to maximize the profit and minimize the output, and actually give a voice to everybody who has nothing to say. And then those few who have something to say, they try to, mute their voice, if you will, because I'm there, and I'm considered now the threat, because when I put my on IEEE Power Electronics Society, I put a mention that that I'll do this course and which time and so on, and they blocked me. You can't believe it, that I'm not only a fellow member of IEEE, but a lifetime member, and this society of what has I don't know, 36,000 or more on Power Electronics Society LinkedIn, and I'm the only one who is blocked from that. They just cancel me from being able to look at anything there. So it's we live in a new world that is dictated by profit and by and who cares about education? In my mind, IEEE has 500,000 members worldwide, but they are really not deserving the non-profit status, because they're just making this field all of a self-advertising and making a huge profit, and having 40-60 conferences per year all over the world, charging the big fees and so on, and really contaminating the world rather than providing a clear education. Okay, that's my personal feeling, and hopefully when you
stay with my courses, and soon they will learn that that's really the case. Okay, so now I will stop sharing. Okay, thanks a million, guys. And hope to see on keep you updated with this update and see you soon on my, I will try to get my 2 recent website that I made, free website presentations. I will also send you this, usually when I have a website presentation, I send you material to study before that. So that's what I'm going to do. I'm going to upload this to Academy 23, this website, so you can study, and then we can arrange for whatever date between now and next couple of weeks to make this critical presentation on a subject that are critically important in this field, and hopefully then we have a more detailed presentation for about 120 hours lectures for 2 months, spread 5 days a week, 2 hours plus 1 hour question and answer, and spread the word that yes, I'm live and kicking, and really excited to introduce you to this technology now, and not, you don't have to wait to 22nd century to take that, to see that happening. So spread the word around, look at what I'm posting, and then we'll see you soon. So again, I think we learned today how to get rid of the bad guys. So at least that was very useful. Thanks for your help and assistance to find those. And I'm, as I said, never been more excited than transferring for what I had in 50 years of this field to you guys, and any new entries in this field. So they find out that's probably one of the most exciting field in electrical engineering to be now, because we are at the verge of, after 200 years from 1821, when electromagnetics started, we now can put it to use, because lucky we live in this earth which generates all this suns and doesn't burn the earth, and it's the only one. I had just to conclude, if you will see it, and I can actually send you, I didn't do that, but I'll send you now. Actually, I'm proud I had worked with this NASA, not only my research, Caltech PhD was all supported 2 years with the NASA. Then when I made my company, the NASA supported from 2007 to 2014, work with the Honeywell, and we built the power supplies, hybrid power supplies, for a bunch of them for Orion spacecraft. And then in 2014, they made a trial run, which circled twice around Earth and flashed down to test the system. But it required much more power to put it out of the Earth's gravitation. So September this year, I had the pleasure to see that finally this Orion spacecraft with the latest Delta, not Delta rocket, which were latest before, but now this latest powerful rocket was able to get out of the Earth's gravitation. And for the first time, this Orion spacecraft went and circled the moon on its own, on the moon's power, basically on moon's gravitation force. And then they had still some rockets to take them back from outside of the weak gravitation of the moon and go back to Earth. And you won't believe it, what kind of that effort is. You're talking about that this little Apollo 11, which was taking 3 astronauts, this new one is twice the size and has 4 astronauts. They mentioned possibly 6, but actually using 4. And 4 astronauts in it, and that is a 5% or 2% of the whole damn thing. Everything else is thrown away on the way up and on the way down. The big rockets with the big hydrogen fuel tanks, and then getting out, and then it has solar panels
which are displayed, and they need 120 volts to convert it to 3 volts, 5 volts, 8 volts, whatever, to drive all electronics inside. So that's where dozens of my converters were used there. And guess what? Is that they throw the 95% of the stuff, but my converters go in next year the same. But next year they will actually do the same thing, but repeat it with the 4 astronauts on board in 2024. And then by 2028 or maybe earlier, the same system will go to Mars and land on Mars. So we are talking a lot of things. I hope I will convince the NASA that some of my latest technology can do much more power and much more space and much more efficiently, so they can put the new systems and going to Mars rather than living with outdated system that is currently capable of much less power and much lower efficiency. Okay, so thank you very much for attending. As I said, usually I gave my in-house presentation due server in 3 or 4 days. At the end of 3 days, I will say, if you liked my course, tell a friend. And if you didn't, just keep quiet. Okay? Thank you very much.
Professor Chuk, question here.
Yes, go ahead.
I don't have access to the Academy 23 folder. It's probably because the emails are going to our company secretary. But the question I have is, do you have the simulations on the Academy 23 folder?
Yes, I do. I have simulation, both of my power, what I call the original Chuk Bak 2, and it was the wrong name. It was better to be called power PWM resonant converter, even though that sounds like a misnomer, but it is actually using PWM, control it, and resonance, so it has all advantages of resonance and all that. And actually, I have the simulation of a single converter, which has a tremendous transient response, and then 2 converters in parallel, phase shifted by 90 degrees, generate that the current on the output is essentially ripple reduced from all ripple down to 5%. So you can have a little capacitance on the output. And the main thing, I'm actually now working to look for some companies who can give me special chip, because what I believe now is, this converter is operating open loop. There is no feedback. No, you don't want to have a feedback, have stability problem. There is no problem with the mode of operation because it doesn't change. Discontinuous, continuous conduction mode always operate the same continuous conduction mode. So I can, if it is 99% efficient, I can operate it open loop, which is great because any closed loop causes what? Stability problem and bandwidth, killing the bandwidth. And killing the bandwidth 10, 20 times makes 10 to 20 times smaller response to fast transient. So basically you're getting everything done. And then you have a duty ratio which changes a little from 0 to 0.5, and you can change it and have at the same time, feed forward to get instantaneous change of duty ratio to adjust for the input voltage automatically in a single cycle, then have a resonant current drawn on the output, so it has automatic drawing the current in the next cycle or 2. So, and of course, what they are doing now? They're doing 12 buck converters in parallel and so on, the whole industry. And I am right now having a project which is also taking my time with Meta, Facebook, that I'm developing new kind of power supplies for data centers, which will be much more efficient and have all these advantages that I mentioned. But industry is very, including very, not only NASA, I thought was conservative, but industry is even more conservative. They would push this, what I call this fake inductors and fake converters like a buck boost, flyback, and forward. They'll push it for next 50 years. And then universities will give lectures on that forever, without trying to understand. Let's move forward. Let's do something better. Not get stuck with what this is. But Chris, do you have access to, you don't have access to Academy 23?
So,
No,
Dr. Chuk, I don't have either. I don't have any access to Academic 23.
Okay, you too, send me the request on my email that you had and say, hey, I didn't get it, I'll do it today. And then I will send to everybody a link, including you and all those who didn't attend. And I'll tell them, you guys are missing a lot of stuff. Now, since you missed it, I'll give you this lecture for YouTube, video, a link, so you can at your leisure look at it and learn about it. I'm all about learning and about making sure that you get your money's worth. That's why I have these courses that when I said, hey, if a company has 3 employees, okay, you pay the 1,200 for all 3 of them. That's 400 per person. I can 400 per person for my 120 lecture hours with the video and all that. I think that's a steal. And plus, you get to learn. The point is, I teach you in 2 months what most universities, including those that I have a bunch of my former PhDs who are professor, won't teach you for 5 years, and you'll pay $50,000 per year for it. So I'll teach you to be power electronic specialist in 2 months, and then if you connect with me on WhatsApp, we'll continue this education, this group WhatsApp when I will propose every 2 months or every month to give a lecture that I respond to your questions. So anyway.
So what is your WhatsApp number to connect?
What? Oh,
WhatsApp number.
Listen, WhatsApp is easy because if you have a cell phone, as I explained, a cell phone is not, everything is cell phone centric. So if you have a cell phone, you just use a cell phone and say, apply on your laptop, apply on your cell phone. Because it's cell phone centric, apply to WhatsApp. Once you apply to WhatsApp, it'll be automatically there, and then you will be able to be on how to say that.
Yeah, so Dr. Chuk, I know I use WhatsApp, but I'm just curious, how do I connect with you on WhatsApp? I don't have your number, or I don't know what is the group?
Okay, well, that's a good point. I will send you my email, my cell phone number, and then you say, I want to connect to you. You actually can say you want to connect to me with either my email, but I think it's probably because the cell phone, it'll be done with a cell phone. And so you can use, if you connect on a WhatsApp, I usually ask that the people put their profile of the picture so I can recognize them, because I have so many 200 connections, so I can recognize whoever is there without the name or without profile picture. So then because the cell phone number that you're connected with doesn't mean anything to me, right? So, and there is a way when you get on that, you just put connect to me as a email, or connect to me using my cell phone number. My cell phone number is 949-887-2375. So 949-887-2375, and you just say, I want to connect with you, and then I reply, yes, great, now we are connected. There is not much. Now, once you have, so you know that, once you have a connection on cell phone, then it's a little bit more complicated to get connection. You don't want to have a web connection on WhatsApp. It's because it's just not the same thing. You want to have a connection on your local computer, and to do that, they usually ask you if you already have a cell phone connection on WhatsApp. Then they'll give you the way that you look through the cell phone, and you want to download local, WhatsApp on your local computer, because then you have the same option as you have on WhatsApp cell phone, because I find it is fantastic, because you get anybody send me information, I get a notification, a sound notification that you send me a chat, some text. I look at the text, I respond on a text, and if you say, hey, let's go on audio, you or I can initiate audio, we can go switch to video, we can switch to that. You can put your status, and the status says, sorry, I'm having a
tooth done this afternoon at the dentist, I won't be available. So you don't try to connect when I'll tell you I'm not available during that time. So that's a fantastic way to communicate. And that's so much better than all the crap that is right now. And most billions of people are using that crap. You know, this, how you say, Google Chrome, Google Access, Gmail, then access through the Outlook, which is even worse, the Microsoft and so on. And the text messages on a cell phone is just useless. 99% is just garbage, you know. But what can you do? You know, everybody wants to sell things for free, right? You know, so that's a really reason behind it. But anyway, yeah, please join and send me. If you didn't get, I will immediately respond to you, especially if you send me an email, because I still use email as a Chuk at Tesla as one way, and I will watch for it, even though I get a bunch of crap emails, but I'll see and act on it. But if you're on a WhatsApp, then we are perfect. Then anything you need and everything is there, send me WhatsApp text and say, hey, can we, and in fact, once we start, after this new course is done, I will then set up probably once a month or once 4 or 5 weeks, I'll set up a question and answer session. So you can, in the meantime, ask me all the questions on WhatsApp or email, and then we'll all get together in a group and then answer those questions and keep communications. The whole point is, I think the whole power electronics is grossly underserved with the wrong information. And that's a problem. And even on my website, Tesla.com, that I have a special tab, which I called Unlearn, you know, and I actually put it on my, I actually put most of that also on my Academy 23, Unlearn. You'll find out that you have to look through those, which I criticized, in order to say, forget about this is all wrong, because you have to first unlearn what is being taught in order to be able to learn correctly. And that's usually harder. I usually like, if you come to the course, I prefer you don't learn any, you don't have any knowledge and learn from scratch much faster and better than trying to unlearn what you have, you know, misfed for the last 10, 20 years through all these conferences and all this nonsense, okay? So anyway, thanks a million for your patience. I hope we have good understanding, and let's now go and work together. And help me out, and I'll help you. Okay.
Thank you, Dr. Shuk.
Professor Shuk, I have a question actually.
What do you say?
Yeah.
Cool.
I have a question. Yeah.
Go ahead. Go ahead.
When will be the next class commence?
We don't, as I said, as soon as I try to, my problem is right now that my website is attacked, and I'm working around the clock to get my website working, and my registration, another website for registration, which is also fast. And I'm working essentially to connect it with at the same time, to connect it through WhatsApp, to connect with all the people who are signing up for a course. So that way I have a direct communication with it, free from all the crap, free from the guys like you saw today, who just wants to make. Can you imagine? I just can't imagine that only human beings are doing that. You know, he got there and jumped on it, and then start blabbering, and then just to prevent me of talking clearly to you. And I had, I'm paying a premium connection YouTube, so I thought that, because the problem will be if I didn't have premium connection, then I'm making a lecture and using this my YouTube presentation, and suddenly it is interrupted with the advertising. Okay, so I solved that problem. Now I don't allow any advertising to go on my YouTube. And of course, I encourage you, go, since you have access now to my YouTube, this all premium, go there and look at the some 100 or so posting that I made over different videos. I guarantee you learn a lot, you know. And I actually also in YouTube, I very often, when people comment on something, I reply to them. So that may be education as well. Right now, I'm also working on making sure that all my YouTube is integrated into the new, let's say, Meta, Facebook, a new Academy 23. So that means you will be able to see all my lectures up directly on Academy 23. So you don't have to go jump to the YouTube and so on. And hopefully soon, I think there is some other benefits. I don't know what is the situation, but seems like Facebook is doing the right thing. You know, they have the Instagram, which is a, you know, instant video communications, and now they introduced a thread, and YouTube is, I say, lacking ability to. It's made really more for, I'd say, attorneys talking to each other, you know, and not circuits, because it doesn't have a simple way like a Zoom with their whiteboard and so on that you can communicate. And that's another thing which I hope we will do in the future. I didn't do it today because I like to make interaction, because nothing better than actually interacting. So YouTube, Zoom has essentially this whiteboard, and you can use to draw on it, and you guys can also use a whiteboard to make your question, you know, draw the circuits, because I can't do that, you know, in YouTube. As I said, you know, everybody can make comments and so on, but it's up in the air. You cannot simply explain it to say, this is wrong, this is right, this is what I use, and so on. You know, it doesn't allow you for really for a circuit people and so on. Eventually, you know, hopefully that Zoom can correct it. I also had my Zoom, without you knowing, but all my lecture today is not just recorded as a video, but actually it's recorded as a text. I paid the top dollars because what I wanted to do is, as I'm making presentation, I wanted to be automatically translated to text. What I also did, I have joined with I have a iPad, latest version, and of Apple, and also I have the Apple 14. And the good news there is I now communicate much easier. I'm a fastest two-finger typist in the world, but that's way too slow, you know. So what I now can use on iPhone 14 and also on this iPad, I can talk to it. In fact, I'm going to see today my local T-Mobile guys to see how to do it. So I can talk to it, it's translated to text, and I'm reading what is made, and then just send the email. Much better way to communicate. Then also I have this latest, Samsung has this Fold 4, beautiful. Forget about this cell phone that I have and you all have, and then you have this, to have to scroll up and down, across left and right to see the whole message. You open it, double screen, and suddenly if you're on a YouTube, you have all the other options for YouTube. You want to jump to it, and you have a whole screen there, and then you can enlarge it and do whatever you want. And the text, you don't need to scroll left and right and scroll up and down. Everything is there, you know. So, and it's not that much more expensive. So it's the tools are fantastic now that you can access, and I'm trying to introduce in my course the best tool which will make this very how you say, very easy to follow, you know. And of course I'm actually now using my studio, which is a Surface Studio. It's a big, I don't know, 36-inch screen, but that I can use a pen, you know, and draw this on a screen. So I don't have to use I didn't do it today because I knew I won't have a time, because that takes a time, you know. But all my lectures are actually having and you will find out a lot of this already posted on my YouTube when I made lectures and I recorded, and I didn't record the whole 2 hours, 3 hours, but recorded made a summary of 20 minutes, 30 minutes. So there are a lot of the snippets on YouTube that you can go from my past lecture and actually learn. A lot of this video are there to learn, but you know, people are ignorant. You know, when I gave a website FIV presentation, and I gave them ahead of a time what I'm going to talk and presentation and so on, and you know what was disappointing? 150 people apply for it, and then what? 20 or 30 show up. You know, this is irresponsible. So why did you bother to sign up if you didn't want to take it? You know what I'm saying? But nowadays engineers want quick results, you know, And that's a problem because they don't want to put a time into understanding things. And that's why we have a problem that we have now. This industry, which is hugely dependent on, how to say, capable engineers to design new system. There are no people who are educated. That's a problem. It's a huge problem. Those people in my generation and maybe a few decades younger than me, they already retired, you know, and so, and all the knowledge went with them. So that's why, you know, consider yourself lucky to get to my course, and because I'm trying to make everything possible that anybody in the world, poor or rich, can learn. But you do have to have a desire to learn. And then the key is, as always, I don't think in the future will be, did you get a bachelor's degree or master's degree at Stanford, Berkeley, Caltech, Harvard, or so on? I don't think that's going to be any more important. What's going to be important is who was your teacher? Because more or less the future of education is going to be online, trust me. And especially now when I can have online, I already paid online extra to have 500 people join to it, okay? And where we are now today, look, you know, of course, part of that is my problem with this, how I say, hacking and all this evil people that you saw today. That, you know, out of this 6 of you, there's one evil guy. So hopefully, you know, what do you expect? When I have 200 people in my online course, then have 20 evil people trying to, how I say. But now at least, thanks to you, we both learn how we can kill them right away, you know, except now, next time when I give a lecture, I said, if anybody intrudes with a voice and so on, because I didn't see it, because I'm busy making lectures, but you see who is on it, and you see, you actually told me the name of the guy was first and last name, and I didn't know how come you see it, but I didn't see it because, you know, I was too busy talking about this presentation, didn't know who was doing. But next time, give 5 assholes like this, you know, or 3 assholes, just tell me this guy, and then I'll look up on my list and then just delete him, you know. There's one click to delete him. So now I want to teach people who are really eager to learn, and I want to get rid of all this, how I say, evil people. You know, there are so many evil people in the world, as you know, that's from whole world. Okay, so enough said. Any other questions? And expect to hear from me very soon. And for first, you get a link to this presentation, and feel free, because this is, since you get this link, feel free to send it to other people, colleagues, and so on, and say, hey, join for the next presentation. Here is a link, and will be a free website, whatever. You don't have to register for it, because I'm using this time while I'm perfecting this setup for Facebook and getting this revived my website and so on. Use that time to really get other people involved and spread the word. You know, this is a place to learn power electronics while I'm around. Okay, knock on the wood. All right. So, and thanks very much, guys. And Andre,
So, Dr. Chuk, I have a technical question, but very quickly, if you have the answer. You mentioned that the
who's talking?
yeah. So this is Assad. Assad.
Go ahead.
So the question is, you mentioned that it is one of the converter you have that needs to no closed loop, is run open loop. But what happens when there is a transient on the output load transient? Then how does it automatically change the duty cycle to?
That's the beauty. That's the beauty of my converter. That's the first converter. Not only did all this. In fact, what I'll do is, as a part of this. It is already on my Academy 23. You just have to find it, because I don't think I organize it. I'm trying to work to organize this material, keep adding it and so on, and it's a lot of material. But since you had that question, I will actually, as a part of the homework,
I will actually, since this is in public domain already, and I don't mind, what I'm going to do is I have my, I say, presentation, which I recorded as a 3-part series on powerelectronics.com, which is there, but that presentation is there and explain everything. But one thing that is brand new, why this is much better than just how I say, the resonant converters, which are hyped up and are not doing what it was supposed to do. My converter here is what I call it DC voltage converter to DC load current. So it is not a voltage to voltage converter, even though it does that. So you can change the voltage to whatever you need. But the most important, the current drawn from output is not dictated by the voltage and sudden change of transient that you ask, but the current, DC current on the output is forcing the full sine wave current with the DC level of the current, and then superposed on it is a resonant sine wave current, which is twice the peak to peak. So that's why it never goes, it has a diode on the output, but diode on the output never sees a current less than 0 because it's sitting on a DC load current, and a sine wave current is drawn up from this. And that means the sine wave current dictates in the next cycle how much peak to peak current will be drawn from the converter. And if the sine wave changes from 100 amps to 10 amps, well, it'll change directly in a single next cycle. It'll have a 10 amp DC and so on. So transient is absolutely needed for this kind of for the first time you're doing that kind of transient. Beauty of that is, unlike this 3-phase and 2-phase system of Tesla, now I have a 2-phase system, which means I need only identical converter like this, but then phase shifted for half a switching period. Why? Because I have my off time, say 90%, and if I switch it for a 50% duty ratio, then what happens? One sine wave and the other phase shifted for that half a period, the two sine waves are out of phase. And guess what? The difference is maybe 5% ripple. So two of them in parallel sync to each other. They create a ripple, so that output capacitance is not what is usually a problem with this all converters, which is a huge capacitance on the voltage to provide a supposed better transient, but it's actually solved by design. That the converter, each cycle is doing that, and what it is, you're making two identical converters and just have a pin on a control circuit which phase shift one with respect to the other. I did that actually without building converter because I use the digital scopes. I save the memory in it and then make another run phase shifted and then use converter digital scope to combine these two converters. So anyway, as I said, you'll learn a lot about this, how to use it correctly, this the plexing program, Plex, and then I will share you and send you up, maybe organize it or send all these people who are registered now, send you this simulation of both, because why is this so useful? Because I already done simulation. I already done a hard part, which it'll take you a lot of time and a lot of knowledge to generate it. Now you'll get this description of the converter. You'll get the presentation of a single converter presentation, two of them are dual converters, and then you can just play with it, play the components and see how fast it is, how the transient is done, because I'm actually going to teach you around how to make a converters like a simulation program Plex actually useful and not how I say mired with all the problems. But of course, So just follow up, and yes, I can send you this article that is you know, it was in 3-part series put on a powerelectronics.com, you know, website, but I combined it to one, and then use this time between now and the next website lectures to learn more about this, what might be, what is already there, but you may not, because there's so much more material, and I accept it's maybe not the best way, you know, put in a organized in trees, so they have, although I have the patents, I have presentation, I have don't unlearn, don't use this and so on, but there is so much information, you know, so that's a problem. But my lectures are actually trying to now, all these lectures I'm making, trying to put a, how to say, importance on several things, so, and trying to get you interested, so you can really see when I'm talking from not only inventor's experience, but actually designer with my own company, building this stuff, and knowing what the problems are, and when our problems, understanding both theoretically and experimentally. So that's I say, you certainly will learn a lot, and hopefully we'll get this with the WhatsApp. We'll get a swell of people to join and to learn from the source. Okay, and again, today is I say Tuesday, September 5th. We missed yesterday. Yesterday was a Labor Day weekend. That's why I shifted to Tuesday. But now be patient for the next couple of weeks, and I'll keep you updated, all of you, with what I'm doing and when we are ready to go full speed. Okay.
Thank you.
So, thanks a million.
Thank you. Bye.
Thank you. Take care. Okay. Let's see, view. All right. Okay. So you see me in a speaker form, right? Okay.
Thank you.
Thank you. Oh, hold on. You hold on, Chris. I have a question for you. I have a question for you. I got maybe from your lady. Your lady for Molly, whatever is her name, Molly Leggett. She said that you asked for a refund, and then I never provide you a refund. Do you still want to do that, or
I need to talk to the management at Mainstream. I had originally asked to get three of my power electronics engineers as part of the course.
Yes.
And Molly was supposed to be taking care of that, and then.
So, but why you're only here, and what about the other 3 engineers that didn't attend, because they all accepted with the same thing, to have access to Academy 23, but you said you didn't have access. That's
I haven't gotten those emails. I only got.
That is a problem. Let me tell you, that's a problem that I fired this guy, because half of the people who sign up for a course didn't get what he was supposed to do. When you sign up, he was just ignorant, and I found out that he's not doing anything, and that's why I had to stop it, because it ruined my reputation. You see, here you have 3 people sign up, and he was supposed to provide all 3 of you access to Academy 23. And then I now find a situation that Molly is sending me, oh, I asked you so many times to return the how I say, the fee. I don't have a problem, and I sent her actually today. I have no problem. Just send me the how you say, wire transfer instruction, and because I can't do it now, because my system of payment doesn't work. If this, I fired also this Sprite, which is you sign up for a course, and then because they are fraud, and I cannot work with them, and I stop all communications. Because if it is working, I could give you a refund directly through the Sprite, but now I can't. So if you wanted to get how to say, refund, yeah, I send me your wire transfer instruction, where and how much. I assume you paid. You actually, for 3 of you paid $400 each, right? So, and I ask her, do you want to refund for all 3, which is $1,200, and
or 400 or whatever, I have no problem with that. And I said, send me that, but be aware of the fact that once, since I have control of my Academy 23, and this asshole didn't have access to it to do the further hacking, so I have control of it, and whoever wants to sign, get the money back, have no problem. I'll send you money back with a wire transfer immediately, but then be aware that I will cancel your access to the Academy 23, which I think is more like 80% worse compared. My lectures are going to put a highlight onto it, but there's so much I can do in 120 lecture hours, but this is more like a course notes for 1,000 pages, in color and so on. So that you can't beat that, And of course, the only disadvantage is that people start complaining and said, "Oh, I would like to download." What do you need to download? To print the papers, to do all this thing? I am already paying for a storage for you up there, and you can access it anytime. You see what I'm saying? But of course, and that's why it is only preview on a box.com. But if I give you access to download and print and so on, and say I need to print it out and highlight and so on, come on, So what do you want me to do now? From my 50 years in power electronics, I want to give away to 5,000 Chinese and 3,000 Indians to give their own courses with my course notes. You know what I'm saying? It doesn't make sense. And a computer, why a paper? We are now paperless society, and I'm doing everything for you. I store a huge amount of information up there. I'm paying for it, and you have access. I'm paying so you can have access, and you don't have to download on your computer with lots of memory, because it may take gigabytes of memory to keep on your computer. Why would you want to do it on your computer just for the sake they can print it out and highlight on a printed version? You have a computer, you have access to it, and then you can highlight it yourself. And of course I cannot prevent people that on a lecture like this guy, probably he could have easily join, and then instead of wrecking my presentation and stopping me, he could have easily use a camera and use a camera to record it. You see what I'm saying?
Yeah.
Record the presentation. But that is a second order effect, because you won't have access to actual course notes, actual things that you need a background to my presentation. My presentation is one part, and it won't be clear, and it won't be clean, and it won't be effective. And why doing that? Because by making my admittance to the card so low, why do you need now to be a worldwide hacker to record it and trying to sell this to other people, my presentation, when they won't get access to all this huge 50 years of material there to study? So anyway, talk to the Molly and your boss, but I would still advise that to have all your guys join, and send me the list of the guys, because you're not the only one who didn't have Academy 23. Send me a list. That's why I fired this guy. That's why he's calling now trying to make a trouble to me with all things. But he's making my reputation going to pots, because half of the people didn't get signed up, and I get complaints, and I keep constantly trying to fix it myself, right? And most of the promotion I did, and he did nothing. So it's just he's really some kind of a criminal anyway. But that's a different story.
Professor Chuk, do you have my email address?
You know what? Send me the email address on my email, CUK@Tesla.com. Send me your email address, and send me email address of the other guys who were supposedly signed up for my course. Admitted.
I sent you an email. I think it was Friday of last week, either Thursday or Friday of last week.
That okay. That's why I suggest please join the how do you say, WhatsApp. The reason is I get all that free from all the garbage, and email comes again with the 90% crap that the people are, and the text message even worse, because the people who are advertising, they send 3 times, 5 times. So I have literally 1% things on a textbook that I can look at it. That's why I moved it, connection with my daughters, individual and a group, and 200 people who are now connected to me in WhatsApp. I want to start fresh with something which works. You know, even though the people generally, the Facebook steal information, this is bullshit. They're end-to-end encrypted. I can now get a course and have WhatsApp with and look, I have access to 2 billion people, and then you don't pay, I don't pay anything for it. Whereas what? Twitter and everybody else is trying to monetize it. Viber is now introducing payment per text and whatever bullshit. They want to all make money once I trick you in, but Facebook is still not free. Why? Because they have so big access that how you say, they're dominant. You know, they're dominant in field, question about it. You know, they bought. WhatsApp is a company which was built by other people, he bought it. Instagram was built by other people, he bought it. Now he started a thread to kill the Twitter, and then Meta, you know, they made the wrong turn, in my opinion, with this bullshit thing. But now they learned and they came back to the senses. So the Meta is now really trying to be more efficient and do right things, including, as I said, you know, trying to build a much better power supplies for data centers, which I have and which they need. And all the other companies ignore me because they don't have it, and the engineer tells them that I'm bullshitter, you know. So what can I do? You know, so
I sent you a message on WhatsApp.
Yeah, send me the message.
I sent it to you.
Oh, you already sent. Okay, you are on WhatsApp already, right? So that's the best thing. You know, if you send me anything WhatsApp, you can on a WhatsApp send me the message, send me the video, send me the audio, photo, whatever. And for example, give me on a WhatsApp the emails from you and all these guys who want to be in, and I'll do it right after we finish. I'm glad you stayed, so we can fix that right away. And
the only issue I have with WhatsApp is that our company doesn't allow us to download it. Because of the CMMC requirements for military work. So I'm going to talk with the IT department and see if I can download it for this. But up to now, you know, we're only allowed to use Zoom for government, that we can initiate meetings. We're not even allowed to initiate meetings right now. They're doing we have to have the customer initiate it, and they're using Zoom.gov.
Yeah, well, listen, you don't have to have your Zoom. You just, as you know, I gave you a link. So you
when
Zoom, and
when you send the link, we're allowed to join. I just can't create a link. But right now, we're not allowed to use WhatsApp, as far as I know.
It's great what you're telling me, because I got the Zoom now to perfection. I'm paying, you know, this stupid. Just to let you know, I upgraded from Zoom Pro to next enterprise level. Why? Because instead of paying $150, I'm paying $1,500 per year. But why? Because that's the next level. I could have a transcription done, and that's important to me. So once transcription is done, I can use a Zoom, and I can talk my lectures and everything. I talk patents. I can get my patents, and it's directly translated to text. So I don't have to type, you know, and all that. But why I pay $1,500? Because I get with it, they always use this monetization. I pay the same thing per license. And with my Zoom Pro, I have 1 license. But this next level that's why 10 times, I have 10 licenses, okay? With the same right. And say, what I do with 10 licenses? I have 3 daughters, I can give them free, all these 3, and they do same transcription and so on, and connected to Zoom, and Zoom connected to box.com to store everything. And what I do with the other 7 licenses, but it's worse. You know what they do for universities? You can get the same thing what I get for this $1,500. You don't want to ask they for a university have education. I'm professor teaching for 25 years, and I couldn't go and get the education license
Why? They ask $18,000 for education. Why? Because you know why? Because university has money. So why should we charge them $15 like me, lousy individual, when they charge them $15,000 and they gave him 15? They gave me 10 licenses. What do I do with the 10 licenses? I need one license with them, but that's monetization. That's their crap, you know. That's but what I say, I kind of find my way in between how to do it. So anyway, that's good news. What you're telling me, that you can. It's important to tell people, don't worry. You sign up in the best Zoom, best lecture recording. You get the link. You get a recorded on the cloud as I did today, and you just send your link and you can look, review it, and so on. But what you worried me about is this: they don't allow you this. How I say? You see on what you just said, because
The CMMC requirements.
And what is that? Tell me more about it. What is that?
You know, it's one of the requirements for government work. You know, we do a lot of work with the Department of Defense, and they have different security requirements. Now, when we have meetings with the government, they typically set up the meetings with Zoom for Government.
Oh, you're telling me that you cannot use WhatsApp for contacting me, like, for example, are you connecting this?
I can use it on my cell phone or on my personal device. So I contacted you from my cell phone, but you were talking about downloading it on our computers, and
you don't need it. You don't need it. Listen, what I'm telling you in WhatsApp on a cell phone is because everything is cell phone centric. They don't realize, if they think they are smart by preventing you using on your computer, they're stupid, because the cell phone is primary way you sign up on WhatsApp. And then if you want to put it on a website, I can understand, because on a website is available for hacking and all that. If it's on your computer, it's available for hacking. But it's great if they tell you it's okay, you can do it on a cell phone, a personal phone. That's what I need. I need all the people who take my course, including you guys. Get on your WhatsApp, get them WhatsApp, and we are in communication. You send me the message, and I immediately get the sound and say, you have new message, and I say, it's coming from you. And I said, then I use that for a connection to Zoom, because I don't like Zoom, the stupid calendar and bullshit and all that, setting the time like a doctor visit and so on. Hey, you want to talk to me? You just send me WhatsApp and say, hey, Dr. Chuk, can we talk this afternoon? I have 2 to 3 hours time they can do. I said, yes, get on. We get on a text message. We get on, switch to the audio there, switch to the video, send you a photo, send you a link for a video and so on, and give you status that I'm available, so you don't try to connect me today between 3 or 7 when I'm not available there. I simply say I'm not available, and everybody knows, whoever is. So that way is very fast connection between WhatsApp and having my Zoom, that I have now everything recorded, and I'm still looking for victims who I'm going to give free access to Zoom. Professional, because I have 10 licenses and I need only one for myself, you know.
Okay.
Anyway, so if you already send it, that's terrific. Send me with your cell phone, and the cell phone is just good as anything. And when your cell phone, you can use cell phone on Zoom, just make sure you use it as a landscape, so you get a little cut off, you know, instead of with this how you say, portrait mode and so on. And you see here, my background is now, I'm grateful for this, because I have only a few walls in my house. It's all this, how you say, from ceiling to, this is high ceiling, but all the ceilings are there for the, how you say,
the blinds.
Yeah, the blinds that you can open up and so on. I keep it closed, but then I don't have the space to put anything on it. So now I using this computer, because I put on the wall everything, you know, this new painting that I got of Tesla. There was another old one which is called how you say,
there's a bunch of my daughters with me and different things. This is my Tesla award, Tesla Pupin award. I have another, I say, the award from, I say, Flunking Institute when I got this award for invention, whatever. So, and this is my famous, how I say, I had the people who are in Academy of Arts and in Belgrade. They made this. We together make this cartoon. When I'm sending to retirement this forward, and now new version. I found one fantastic cartoon. The cartoon has the guy pulling the cart, and the cart there is a bunch of stones, and then it's like, and he's like a caveman, and then the cart with the stones is pushed by the couple of cavemen behind it. So they're all together moving this cart with a lot of stones, and then cart has a square wheel, and then there's another caveman going to them and using a round wheel, and he's offering a round wheel, and the guy pulling it says, "No, thank you, we are too busy," So I'm now making a modern version of that. Instead of caveman, the guy offering round wheel is of course going to be a copy of my things here, like I'm an inventor offering them a round wheel. The cart will have, instead of the stones, will have a new converters, and the manager the guy who is pulling the cart, he's a manager of the group, and the other putting back engineers who are just like following his manager, and the title will be like what I'm saying, power electronics, I say, for 22nd century or something like that, So we finally graduate to round wheel and use innovations to push this car, and of course the guy on the front will be in a tie, and the engineers behind will be in a not rich to have a tie and a suit, so they have a Levi's and some other things. Anyway,
Professor Chuk, I'm very interested in these type of resonant converters. And if
that's the future. So let me ask you, what is your company name? Is it
Mainstream Engineering?
Okay. Do you do any IC chip design or use any custom-made IC chips?
We typically purchase the IC chips. We do some. We have 5 different groups in engineering, and one of them is working on like oxide layers for silicon carbide and things like that. But we don't make the full chips. We have material science and chemical engineers, and they do depositions and things like this. From our electrical engineering side, we focus primarily on the application for power electronics.
Because one thing again, where the whole thing is misplaced, I can generate what I have means control circuit that I have is on-time control and off-time control. And you will see in my presentation, when I'll send you guys for my Chuk Bak 2 or PWM resonant converter, what it is that I created this, what could be separate custom chip. I created it with a Plex program because it has a great advantage over other simulation program that, like in a Fortran, you can make a couple of statements and make a subroutine, which does this input to output, but you convert it. So basically, I made a controller on a Plex, which is on-time and off-time control and both. So, and then I use the on-time control to change the duty ratio to provide a right conversion of the voltage on the output, and also use ramp generate internally to control like a feed forward. So if it changes, suddenly this feed forward is controlling the heights of the ramp and automatically switch. If you go from 36 volts to 72, next cycle, you won't even see it. There's no transient because immediately you call forward, it's not feedback. But then the feedback, because the way it is made, in my case, then the feedback, if I have a constant off time and during off time of 90%, I make this sine wave. And since it's constant, it always operates. Whatever current changes, DC load current, it always in that time and provide all advantages for that. And then I don't have a feedback for it. Why? Because if I have a high efficiency, 99%, what is the feedback for? It's only to adjust for a little drops on losses from full current to low current. And I can create that simply by sensing the current and say, hey, use this reference, change a little bit. Reference is changed proportional to the current. So another composite for that. So I don't need a ratio because it's 80% efficient converter to change a lot to a composite for losses from full load to no load, of course.
Yeah,
But
so we could do that in one of these real-time micros or in an ASIC. We do this all day long. We design our own controls. We use primarily TI micros.
Let's talk, Chris. Let's talk about what you do with. I know microprocessors are very powerful, and if you have a way to make a microprocessor do that, I don't care. Microprocessor is make this kind of control. I found out that I can do it now, but it's kind of a rudimentary way. I found out that 555 timer, which was bread and butter in electronics for 50 years. Now I looked at it and people say, oh, 555 timer, it can only control duty ratio, right? One duty ratio, that's what it's made for. But actually, it turns out you can control on time and off time independently by using 555 timer and then use additional external diodes to it to control independently on time and controlling independently off time. That's exactly what I need. But it's kind of kludge because now you have to have diodes to control this on time and off time separately and so on. And it doesn't do this feed forward, which I would like to do, to have a ramp change according to the input voltage and so on. But that's for a chip. It's simple. But you know what? That chip is a future for my all future implementation. DC to DC converter, DC to AC, AC to DC, all of the stuff. Because that's, at the essence, I always said, the whole power conversion depends on DC to DC converters. Once you have that as a basic module, you can extend it to DC to AC, AC to DC, AC to AC, the whole stuff this is a fundamental module in it. And that's why I'm looking at making battery charger from electric cars, which takes all advantage what I have. And then you have two converters like that, isolation transformer, which is much smaller than, because it's not proportional to frequency, it's proportional to pulses and whatever. Anyway, so I make a converter, which is now 80 kilowatt converter. I can put it in a car. Why do I need the 300 miles and nobody can put 80 kilowatts? You know why? Because they all have a stupid fake inductors. And the fake inductors have an air gap, and the air gap limits your curve, limits your, you have to put air gap, and at 1 millimeter air gap, you already lose 90% of inductance. So, so it's almost like an air core transformer. Who do you want to work with air core transformer? It's huge currents and so on. But if you have get rid of this fake inductors, have a transformer, which is true transformer, which which I am doing now, and you can make much smaller transformer, because the transformer is at the essence of why we are stuck for this 50 years. And as I said, watch me next year or two. I think there will be a revolution, and hopefully I'll transfer that in not only in my patents I'm applying now, but transfer it in the textbook. because there is no textbook in this field, and everybody is rehashing all the crap stuff, old stuff, and teaching wrong stuff, and trying to make themselves the geniuses, like Elon Musk, as I said today. You know, hey, the guy's making Australian government paying megawatt of batteries, and then he needs to convert 10 megawatt into the alternating current and feed it into alternate utility line. Both terrible, and not related to self. And what? Ignoring that the real source of the power is the solar, that we all actually benefit from it. But anyway, that's
so I'm sure you know the problems they're starting to see in California. They saw the first time ever in history a negative demand in the power grid in Australia because of the solar, and now they're starting to see it in California. They used to call it the duck curve, and now they're calling it like the plateau curve. I don't remember, where they're concerned that there's going to be more solar generation than there is demand on the network, and that was the big problem in Australia. And they actually passed a law that they can actually charge the consumer now for putting energy on the grid. But they don't have the mechanism to do that.
Are you kidding? I can't believe it. The first time I heard from you, when I started my company, my basic contract at that time was from Sandia National Laboratory. And what they wanted to do, I developed with this guy, Alan Kokoni, who was my master's degree student, my first engineer, and he was designer of this, when he left my company, he designed for General Motors this first all-electric car, which is they call
the EV1.
EV1, and actually General Motors wanted to pay him $2 million a year to work exclusively with him on that, and he was always very strange. He didn't want to work for anybody. He says, the only money I work for is you. When I had my company, he was my first engineer. He left Caltech as a master's degree student, and then built this solar car, which won a race in Australia, and then built for them this Roadster, first car, and which, of course, Elon Musk bought away with his, eBay money, and then the rest is history. They stole the whole thing. He had a patents on it and so on, but they took it over. But the whole point I'm saying is, when I started with the Sandia National Laboratory, in my company, with his help, he built the first 4 kilowatt photovoltaic converter, which will take the battery, convert the solar cells power into utility line, because we had DC to DC convert the front stage, and then what's unfolding stage. So use the 4 transistors to unfold it into the sine wave, and then put it in phase with the sine wave voltage. So we were actually making 4 kilowatt converter, which was costing like $4,000. And then 4 kilowatt was what Sandia said, a family of 4 will get the free electricity. And at that time, government, when I started company, which is 76 and so on, and got this Sandia national contract, the government was asking, all utility companies were required, opposite what you're saying, they're required to pay you for a amount of power, measure the power that you put in utility line from solar input, pay for you, but of course, they will use a different rate. They will change you, you will pay for them, I don't know, 10 cents a dollar, and they'll give you back 2 cents when you put back 3 cents. You know what I'm saying?
Yeah.
But the point is, they're encouraging this such that during the daylight, you're creating the power which are needed extra. The only limit, because that converter was made what we call utility interactive. So it was not capable of handling the power factor, you know, so it was only providing real power. And therefore, as utility has to provide both real and reactive power, the utility was still providing complete power because it drives the motor, you have reactive power and so on, and power factor and that kind of stuff. So limitation was it providing real power, you know, active power, so to speak. And that's what simplifies the design of this converter. Just DC to DC converter, simple. At that time, we used push-pull, and then there was 90% efficient, and then you use a unfolding stage to convert it into sine wave and put it, and then there's a control to put it in a utility line. And we designed it for kilowatts. We sold 10 units, and 9 of them or so were sold to all these, I say, all these companies in the world which were doing solar power to. They bought it such that they can do reverse engineering, see how we did power, how we tracker, you know, like tracking the power, and which was actually had some inventive things how to do it. But what I'm saying, this is ridiculous what you're stating me, that customers will pay utility when you're actually able to create huge power. And the bottom line to that is, it's a wrong way that I explained today in my course. You know, it's you fully don't understand electrical engineering. Like Elon Musk, you know, he's putting a megawatt batteries to instead of solar cells, putting into a utility line or a DC line. Okay, looks like someone is on my. Let me see. Someone is at the door. Let's have to see for a second what it is. Let me just for a second. Oh. I know what it is. Nobody's at the door because I'm upstairs. But what they do is they deliver something, UPS or FedEx. They just ring the bell and drop it in front. So I'll go and check it out. Okay, great. So we have full understanding. Please, you already sent me their names. After I sign out, I will put them right away to have you and them have access to it. And then you figure out with your bosses if they want to get money back or this is money well spent, you know. So it's up to you to convince them that it will be best spent money they ever done in their company, you know.
Absolutely.
Okay.
I don't know if you remember, Professor Chuk, I worked with you almost 10 years ago with TechnoWise.
With what?
With TechnoWise, we were having meetings with you about 10 years ago.
TechnoWise?
Yeah, TechnoWise, a company in Boca Raton.
Oh, Boca Raton. I remember I had Israel wanted to work with me. It didn't happen. But why don't you refresh me from that? What was it, 10 years ago?
Yeah, it was about maybe more than 10 years ago. About 10 years ago or so. The guy working with you was named Steve Mansfield.
Steve
Mansfield. We were supposed to.
I usually remember. I'm not one of these dementia or Alzheimer people. I remember everything from 50 years ago. So
yeah, we had a couple calls with you, and we're supposed to meet with you in California, and he ended up leaving the company. But we're working on an AC to AC converter for Mexico.
Oh, I see. So basically, he was originator, and then he left the company, and the thing died down, right?
Well, he wasn't the originator. He was just one of the engineers working on it.
One who was in the loop connecting with me, right?
The one in the loop connecting with you, and then he left the company. But we were supposed to go to California to your company, and we never did. It was supposed to be, Steve and I. Yeah, we're working on AC to AC converter. Basically, the grid stability in Mexico was a big problem, or still is a big problem. And they're having a lot of problems in neighborhoods where you would have the first house had over voltage and the last house had under voltage. And of course, we know the grid stability issues there. In the US, if you have high voltage or low voltage, you typically have that throughout the day. Theirs was, traveling throughout the day and causing a lot of problems with their, with their appliances and devices. So a very wealthy guy that owned, a lot of the textile industry was having problems with the sewing machines. So we're making these AC to AC converters for the textile industry, and then it started going to other industries. We also worked in the oil and gas industry, but I haven't been working for that company in about 3 or 4 years now. I've been with Mainstream Engineering, doing mostly government work. So one of them is this, Moon to Mars initiative. And are you working currently with any of the Moon to Mars programs?
Which what program to Mars? What is that?
Moon to Mars initiative.
What is that? I don't know. We gotta talk separately to update me on that, because let me tell you where I did have this converter built with Honeywell team, who were for 1 year in my company, and they have actually helped to convert our prototypes from commercial parts into the military and do all the bloody testing and so on. The only problem is they are no longer in it. All the people in Honeywell, they're replaced, and then they have other companies took over. A guy who he had some accident, he's rehabilitating a home, but he told me that the whole original group who worked there is gone. I actually visited NASA in Huntsville. Why? Because they were interested in my converters, and I actually not only Huntsville. I was actually in where is the headquarters in.
We're going to Cleveland on Monday.
Well, anyway, the point is, I contacted them. They contacted me and paid me to give one lecture at the NASA headquarters and so on. I paid for my trip, of course, and gave a lecture and so on. And I gave also a lecture at the patent office there. And the thing is, I talked to them and I said, I have new technology that is now, instead of having a 100-watt converter, because all of this classical one, which I at the time had two converters, had inductances in it, had limited in power, although they're efficient. But now I am, in next 2 years, what you're going to see is, and I announced briefly today, I'm going to, completely revolutionize power electronics, and it'll be power electronics revolution now, not power electronics revolution for 20th century now, not waiting for it. And reason I'm saying is because I think what I've done so far is it prepares me to have a understanding of all problems and issues, and then as anything to make the final full advancement. It takes a lot of effort to make it much simpler, as I always say. Do a lot more with smaller number of components, and a lot more, meaning eliminate all this limitation of scaling up the power, because none of the converters up to now were able to scale up in a power, and that's a problem. So now, for the first time, I can scale up this to DC converter. I can do the same thing with the power factor correction, and they're all limited in current and power. And now, when I have this, and of course, it's all is here now. You have all the components, transistors, which it can be not just, like a MOSFETs, which operate in 2 quadrants,
and conduct the current bidirection. We have a voltage bidirectional devices. People don't realize that. You know, if I have an AC input, I want on my AC input, when it's positive sign, I want to work in the first quadrant. When it's a negative sine wave voltage on input or sine wave, I want a negative voltage and negative current. And there is device already. I already told them many times this what is this? Efficient power conversion, EPC, and say, hey, you have the gallium nitride device and you're not using it properly. You have a big advantage of it that you have a drive included and you can make it a voltage bidirectional converter. And then later I learned
it doesn't have the intrinsic diode.
yeah, the diode is actually what kills it, you know, and that's why I had to use two MOSFETs at the top of each other and a floating drive to emulate two-quadrant converter, first and third quadrant, positive and negative. Now, the Panasonic made this gallium nitride, which is with the two gates, and then you can have a, how you say, in a single device is operating as a for positive voltage and positive current and negative voltage and negative current. So it's voltage bidirectional. And you know, advantage is they made a device which is 400 volts, no, 600 volts rating, but it had the 3.5 milliohms on resistance for 400 volt device, you know. I said, hey, everything there. You know what happened? Panasonic sold it because you couldn't pay any business, sold it to some other company, bought it. And here, this kind of device can operate as a rectifier and diode and can operate as active switches, you know, depending on these two gate drives. And you know what? They're stupid because I'm saying all my DC to DC converters, if I put on input side sine wave voltage, positive and negative, I need zero. I need a single device which is operating in the first and third quadrant, done deal, you know. And instead of 35 million on output, I have a diode, and if this operating like a 35 milliamps, can you imagine 400 volts, 600 volts on the output, 35 milliamps, you know, 10 amps, you have 10 kilowatts converter, the drop on it is nothing. And not only that, I'm talking about conduction losses. But since I have now where my output diodes are operating at zero current in all conditions, and input switches at zero voltage in all conditions, hey, you have everything there, you know, from a DC to DC converter, you had additionally AC input or AC output, depending what device you connect. People didn't get to graduate to that, you know. And as I said, you know, the company which was Panasonic, which is a big company, they didn't have a use for it and they sold it to someone else. And I don't know who is someone else who is pushing that, you know. But when I'm telling you, this our field is so much backwards that it's incredible. And I'm trying now to send me information what you have of this Marsa, because basically I'm trying to connect to NASA now and say, I did all this work for you here, and it's 100-watt converter. So how about putting 2 kilowatt and 10 kilowatts, you know, which is 10 times smaller in size and 99% efficient and no feedback and no nonsense, you know. But it's hard because you know, typically the managers are in charge and they make a decision. And the problem is most managers, as I said, they are grown on the management side, which is, and then capable engineers, unlike in Japan, the most capable engineer becomes manager. In the United States, the stupid engineer becomes manager, right? So that's a reverse, how you say. So let's keep in touch and let me know, send me by email or WhatsApp, what is this Mars project? I'd like to connect with someone who is interested in the future, how to put this, and also look, you're in a military business. I can tell you what I can do now for a military business in terms of size, weight, and efficiency and control, eliminating the, how to say, stability. I know I got into this field because Professor Middlebrook was working for TRW when I applied to Caltech in 1972. And TRW had a boost converter, and a boost converter was horrible, known for even though two poles, I mean, two inductors and capacitors, so it's a second order system, but it had this notorious right half plane zero, which acts like a pole and therefore provides additional 90 degrees phase shift. And instead of less than 180, you have 270 and it becomes unstable. So they had a problem. They had on a satellite boost converters and they were oscillating, you know, and a stability problem and so on. That's why he went into this. And when I came at Caltech, first thing is to analyze all these converters. And then I made my state space averaging. People learn about it, that. And I said, it's not only for now, but it's for any future converter. This is solving the problem. And the problem I didn't know at that time, that I'm going to actually obsolete boost converter. And now say, I will make a step up converter, which doesn't have that stupid inductor. And I'll make step down converter that doesn't have that stupid inductor. But the people are not buying it. Even when I'm making for years this in-person classes and also now online classes, they don't get it, you know. And I get the people from Intel, from India, oh, they're interested in the converters and so on. And then I can't convince them that the stupid 12-buck converters in parallel is just what you should never have done that, you know. 1 buck converter is bad, but 12 of them in parallel, you know, how stupid is that, you know? It's you know, but we live in an ignorant world, because a lot of, as I said, a lot of that knowledge was lost, especially in magnetic topologies and so on, and a lot of the quote experts who are contaminating the field with the nonsense. And first, most ridiculous is IEEE with 500,000 members, biggest professional organization, and they're just milking their non-profit status and making a huge amount of money, right? Because they team up with the conferences, and the conferences show the people who are now new gurus and so on. But this is, and you can tell them they're stupid, you know. If you tell them they're offended, then they won't even come close to attend any conference or be on any forum, you know. It's a travesty, really travesty. But update me on what is this program that you have. Maybe we got to right people and tell them what's available nowadays, because I'm really excited to hear, especially this is not just a space program. Same thing for military. You always have a need for a smaller, more efficient, and lower cost. And I always said, hey, if I can make you now 10 times smaller and 10 times lower loss and 10 times lower cost, oh, it's only 1,000 times improvement, you know. But normally what they say is it's a trade-off. If you want to make a converter more efficient, okay, you can get 2% higher efficiency, but now it's going to be twice the size, right? You know, and then if you want to reduce the cost, you know, okay, so again, you're going to make it much bigger, but at lower cost, you know, because you're going to put the heat sink, and you're going to put it. Heat sink is much cheaper than how you say, than semiconductor devices and so on. And when I was in a Google 2 years ago, when I gave this talk with APEC locally here in Long Beach, I came up and said, the guys who are presenting this stuff, and said, you don't know what you're talking about. You know what they did? The guy who was talking, giving a invited talk of how to say advances in power electronics at universities, and who is you? You're not even a professor, and you're just bullshitting. And I got up, and he just did this, and later with the headphones, he's controlling the microphone. When I was talking in the microphone, they cut my microphone, and there was 1,000 people. I was talking in a dead microphone. I have recording of that and so on. And I'm saying how bad this field has gotten. You know, you couldn't tell them because if you tell them, they just get offended, and they don't want anybody who knows anything to voice that you are all, how you say, barking up on the wrong tree. And that's really what's happening in the field. So yeah, and after that conference, I had a couple of people from Google and said, hey, why don't you give us a lecture? Because they want to reduce the 60 hertz high voltage transformer, maybe using, as I was talking at that time, maybe I can make a high voltage transformer much smaller because they lose at 60 hertz, they lose a huge power. They have this high voltage transmission, but then they need a big air conditioning building just for cooling the transformer, and data center power supply operating at 80%. They have another bigger building to cool the data center power supplies. And of course, when I making the talk, the guy who is a Chinese master's degree, whatever, and he had a group of 8 Chinese engineers at Google. When this country is a fight with the Chinese now, you know, and so on. And he said, he showed up in the morning and the engineers were busy to attend my 2-day presentation. And in first day in the morning, he showed up and he discovered to me, you know, Dr. Chuk, I have 2 group engineers. He's not his manager, right? I have 2 group engineers. One group is looking at the third-party solution. They have 8 PhDs, all Chinese, working there, making a huge money, probably $200,000, $300,000. And they are evaluating third-party design for these DC converters to drive microprocessor, which is a big problem, right? And he said, I have 2 groups. One group is looking for high efficiency design, and the other group is looking for third-party design with, which are low cost. And he discovered to me a great secret. Listen to this, Dr. Chuk. I don't even look at this proposal for a group who is collecting the, how you say, third-party design for high efficiency. I only look for a group which is doing low-cost design. Can you imagine such stupidity that he is a big manager? He has 8 PhDs from unknown universities all over the United States and elsewhere, and they're looking for a low-cost design, and they ignore efficiency. And efficiency, and the whole ball is about efficiency and performance, of course. Like as I said, you know, even you know what, you know how the space shuttle. I give all of these up a control system. I finally graduated to the point that I don't want to use the feedback, because the feedback was solution in good old days. But stability is a huge problem. And you know what? They had a takeoff and landing of a space shuttle was controlled open loop. They banned the feedback because what the feedback does, uncontrolled, and the whole thing is just collapsing and going down. They want to, and how did they open loop control? They have big computer on board. So what they did did the testing in a tunnel, and when they change the angle of attack and so on, reduce it or increase it, angle of attack to be able to slow down and so on, they're testing that in this kind of a wind tunnel, and adjusting what they're testing. They're making control system is have side winds this way, side wind that way, up and down, and then their control system is sensing all of that and telling how they can control this. But it's not. It is just a simulation of conditions, and then built in a computer to adjust to external influences, but no feedback, absolutely no feedback. But even despite of that, the last one burned. Why? Because when it was taking off, this such a high temperature, the ceramic things were burned, some of them, and they didn't know, they didn't test that ability if they're burned or not. So when they're coming down, there's like a hole in which essentially they burned from when they're coming down and then just exploded in the air. You know, too bad for 7 astronauts. You know, but what I'm saying is that this whole thing. I'm happy where I'm now at. You know, that my whole how to say learning curve is all the time prepared me to where I'm now. So I can look at the whole world and kind of look at this. Come on, you're kidding me. What are you doing? You know, it's just I can't believe it. You're still, how you say, you can get the basic principle, which I point out, and And, and of course, a lot of companies are driving this whole country in the ground, because why? They're not interested in innovations and going forward. They're interested in, how you say, monopoly. And a monopoly, I said, is killing this country, because monopoly of Google, monopoly of with one way, monopoly of, in fact, of the Apple, another way with a consumer product, monopoly of Bezos and his selling and buying and selling, which is actually not cheaper, because right now you can buy cheaper than Amazon, but people have this ingrained that oh, you can order it Saturday and it'll be Sunday morning at your home, and that kind of convenience. So it's this country is really going to have a huge problem, and especially military, because they won't be able to keep up with the Chinese, because I would say with all bureaucracy, the bureaucracy of big military companies. I've seen it. I got I would say a Boeing contract and so on. I've seen it. They would send, gave me contract and Tesla, and I remember, they were working for 2 years on 3 different converters, providing 3 different outputs, and then they came back to me and said, "Hey, we worked on it, we didn't succeed, but now they want to make one converter does a triple output." So they gave me design to do it. And they sent their engineers to Tesla, and while they were supposed to work with us, my engineers were slaving and so on, and they would go and spend most of the day on the beach, considering that's like a benefit of working at a company. And then later I learned, when I visited, Seattle and visited them,